already a few minutes behind schedule. We want to give you time at the end of the day to, if you didn't go through the aquarium yesterday, to do it today. So once again, my name is Warren Mallon, and I'm going to be steering us for the session up until the end of, before lunchtime. So yesterday I think it was quite interactive and a lot of discussions that were had. Prevention seemed to be the common theme, and hopefully we'll be continuing with that today. We've got another packed program with some more diving-related activities and some of the other hazards that you wouldn't think are associated with diving, but they actually are. So with that, I'm going to get us going. So up first, we got Mr. Mike Essop again. He's going to be going through the developing an effective occupational health and safety management system for commercial diving. So just those of you who maybe didn't hear him present yesterday, Mike is the CEO of OSC Marine Group. It is a multinational subsea engineering company operating in Africa, the Middle East, and South America. He is a marine mechanical engineer with a master's degree in business administration, and he started his career as a naval mechanical engineer in the SA Navy, and in early 2000 co-founded Unique Hydra, an engineering and equipment manufacturing company for the marine, offshore oil and gas industry. Mr. Jessop has been involved in the manufacture and operation of various diving and subsea systems since 1994. And he has been presented at many international conferences and is one of the technical authors of the IMO diving operation regulations, which he also touched on yesterday during his presentation. So with that, Mr. Essop, if you can come through, thank you.
Right, good morning everybody. I have the opportunity to talk first, so you're well rested today. Thank you. It's a great topic, occupational, trying to understand the management system. So I'm going to give you a bit of a broader overview of the industry, the offshore commercial diving industry as well, just so that you understand how a safety management system fits into that type of work as well. It's quite important for you to also understand the context of a management system. And it obviously varies in different spaces, from school to a commercial diving operation that happens in marine civils, to dam work, to offshore oil and gas. So it has a variety of different applications. So it's important for you to understand that. At the end of the presentation, I've also got a video. That video just highlights the typical offshore environment that we work in, and it just gives you a bit more perspective of how the management systems will function. A bit about us. 1962 is when we started as the original Cape Dive and Salvage. We rebranded in the middle 2015-16 into OSC, and we've been recognized with IMCA for many, many years as an international marine contractor, both in the diving and in the ROV work scopes. And we obviously apply the latest technologies, etc., to what we do. Our locations are all over the world, basically, predominantly within Africa, East and West Africa, and Southern. A little spot there out in South America, Guyana. Not many of you know that name. Next to Suriname. There are two little countries that are very rich with gas developments nowadays. And so we operate there for ExxonMobil in their space. And then the Middle East, which is predominantly a large hub for commercial diving. This is the typical environment that we work in. You can see the offshore refineries. So quite complex pieces of equipment that sit offshore. Accreditations for ourselves, we have the typical ISO 9045 and 14. So that's under safety as well as environmental and quality. And then we are accredited by a number of class societies for the work that we do on these structures offshore. Services that we offer, typically what you see there in some of the pictures, that's a fairly recent job that we're on up in Mozambique, offshore Palma, where we're doing an ROV inspection of that large platform. That platform basically is a floating refinery. It's almost 400 meters long by 60 meters wide, so quite a large piece of steel, and that requires inspection and maintenance and repair on it. And then the picture below you'll see is typically how we operate some of our ROVs on some pipelines inspection. So all the equipment that you have below the water, pipelines and structures, we need to look at them, inspect them, repair them, maintain them. Just some examples of the environments we work in. This is, we installed a diving system onto a FPSO, floating production storage offloading system. So again, a floating refinery. So we actually installed it on board, and then we dived off it. So with that goes, gaseous zones, zone rating requirements. We're working at height, as you can see on the top right there. That basket is actually a manned basket. There's 2 divers in there. They're being lowered down into the sea, and then they operate below the waterline. You see that little passageway. We had a bit of a challenge to get some equipment through, so we have to engineer equipment to get through their rollers and structures and logistics to make it happen. That's typically our launch and recovery systems for the divers that we then move into location, and we then will dive from those platforms and structures. That's the underwater world. We had great visibility in that location, almost 20 meters of vis, which is unheard of. But that's typically what we do. We clean and locate the infrastructure, ready to receive the equipment, the risers that are coming up from the seabed. And that rigging assembly that you see there, that's almost 4 meters tall, that sheave, that yellow sheave there. It's almost 4 meters. It weighs practically 40 tons. So we do a lot of offshore rigging, lifting plans, and very specialized process of being able to get this equipment into location, tie it safely without hurting anybody. So very, very specific risk assessments and processes and critical procedures that we go through. That's the final solution. So what you see there is, in effect, we just had to connect that. Can you guys hear me at the back again? Yeah. We had to connect the gas riser, which is that pipeline that's going down there on the main picture. We had to connect that gas riser to the FPSO and then bolt it together with underwater tools and torque tools and stuff like that. So, and that takes almost 6 months of planning, 6 months of discussions with all of the stakeholders, the vessel, the owner of the site, etc., just to get all the procedures right, trial it, and then execute. And actually, it's only a week of work to do that. But because we were so slick in terms of the critical procedures and stuff, the execution was fast and effective. Obviously, it takes a team. It takes an incredible team. And that's a South African team. So we're very proud of what we do and how we do it, from the project management team to the actual team that's executing the work. So it's great to see. There we go. Right, now let's go into safety management system. How do we make what you saw there actually take place in a safe manner? So by definition, an occupational health and safety management system is a structured framework, and that enables the organization to manage and improve the health and safety of employees. And it runs across the whole organization, from the leaders to the operators to the types of equipment to it runs all the way through, documentation, etc. Understanding an effective management system, or just some of the main links that are important here, is pre-job planning for high-risk work. It's very important. Adopting what we call the life-saving rules, which I'll give you some more detail of. Obviously, written procedures, what we call a hierarchy of control, very important to understand the hierarchy of control on a job site. You don't want people wagging the tail. You want people to be clear as to who's in control and what their authority is all the way through. Very important part of it is engaging in lessons learned. You learn. Everyone learns as we go through life. How do you adopt that learning back into your organization so that the lessons you learn on a job or the near misses or the potential near misses or a consideration that the guy says, hey, we were at a little bit of risk here, let's make sure next time around we don't have that risk going forward. So it's enabling that lesson learned culture to occur in the organization without people being pointed at or being isolated in that sense. So it's important that culture comes through. I'm hoping you guys can see that graph. So just to explain the graph there, on the left-hand side is basically the number or times that people are hurt. So let's just say on the left-hand side there's a lot of people that are hurt. Let's say 100, okay? And over time is on the lower side of the graph. So if you only had a regulation, okay, you only, in your management system at your office, the only thing you ever really worked from was a regulation or a code or an occupational health and safety thing. Well, then you're going to hurt people. Make sense? There will be people hurt. But the biggest change you can make to the number of people that you can hurt as an organization is having a management system. Look at the drop that you see there. Having a management system significantly reduces the number of people that are hurt. And if you don't have one, and an effective one, you are at that level of risk. Then you go into behavior-based safety, which is a term used in occupational health and safety in terms of how to identify and work with people on the front line in terms of making sure that they're able to adapt and understand risk and see risk as they go through it. Then you go to hazard recognition, enabling people within your workplace to identify hazards and identify them correctly and deal with them in an appropriate manner. Then you're going to approaching others. Approaching others is typically like IMCA as an association. It's an association of common types of organizations that share their safety concerns, share their behaviors, share the lessons learned. So you're approaching others. You're learning from each other as an industry to self-regulate and prevent injuries as you go through. So belonging to an association in your area of expertise or area of work is fantastic. That also helps to reduce the number of people hurt. And then the last one is human performance. That's fairly new. It's maybe 10 or 15 years old, where people are driving organizational cultures to enable the leaders to adapt to their workforce, to allow people to make mistakes and report on it in a manner that is not seen as subjective to them. So being able to be open, to say, hey, I made a mistake, I'd like to learn from it, this is what's happening. And then the leadership within that thing work with the workforce to adapt the working environment. So that's known as human performance. It's a whole topic. If you'd like to learn more about that, I'm happy to share a little bit more about that as well. It's very big in the offshore space, and it's making a significant effect to the safety management systems. Pre-job planning in a high-risk environment. This graph is typically the frequency of jobs versus the risk. No one tool actually works when it comes to critical jobs. It's a multi-tool application. High-risk environments require multiple tools to enable you to understand the risk and manage it as part of your company. So what you see here is a mental risk assessment. You allow the guy to arrive at the job site and he looks at the risk and he thinks this is okay and he carries on. So it's on the onus of the individual to make it happen. Then you go to a number of different other tools that are available there, from safe working practices to normal procedures to life-saving actions to critical procedures. So there are a number of tools that you need to engage with. So if you're not engaging in a number of tools, you need to think about it. You need to rethink your management system and go, hey, I work in a high-risk environment. I should have multiple tools to work with to make this, to understand your risk. Critical procedures, just an example of what critical procedures look like. You saw what I showed you earlier. You know, that sheave is a monster. So if you think about it, I'm putting that sheave in the water, there's currents, that sheave's going to move around. If that sheave hits a diver, I'm going to knock him out properly. Or I could, if it's actually free moving, I could crush him against the side of the hull, and he'd be a pulp, basically. So there's a lot of risk involved in what we do and the environment that we have to work with. So critical, so we actually create diagrams, like you see there, in which we create all the method statements within those diagrams, and we teach them to the divers in a visual way. Why? Because people don't necessarily see things from reading something. So we understand what works the best for people in our work environment. And that's seeing something. Even better would be a video, but actually videos, they cost a little bit more, but this gives me exactly the same functionality and puts the message across to my team to say, guys, understand the risk. This is what you're going to be doing. And step by step, we take them through what they need to do. And then on the surface, we actually walk through that as well. So we walk through the procedure with the divers before they're even underwater. We walk through that same set of criteria. Why? Because body memory is so much more important when you are actually down underwater. You want to really understand what you're doing all the way through. Life-saving rules. For those with a camera and want to actually grab this, you're welcome to scan the QR code. That'll take you to the life-saving rules. These are industry standard for a offshore oil and gas type environment, and specifically diving. It gives you fantastic insight into the different life-saving rules that you can easily adopt in your management system to take you one step further to having a safer working environment. It's simple. There's videos available for you to show your team. So all the tools are actually available on these sites to actually teach your team, to induct your team, to familiarize them with, working at height concerns, safety concerns, energy isolation, i.e. isolating electrical energy or mechanical energy before you go and work on something. So there's a phenomenal amount of information available to you online. I think many of you will recognize this. It's quite a common indication, hierarchy of controls. All of you have worn PPE in some way, correct? Yes? Great. But do you know PPE is your last measure of safety? It's the last thing that you put in place when you look at something of risk. The first one is elimination. You want to try and eliminate it. Sometimes it can't be done, and that's 100% correct. Other ones, you replace the hazard with substitution. Engineering controls, putting some sort of engineering controls in place to eliminate it, or administrative controls, which is procedures, methodologies, etc., how to try and manage it. And then the last one is PPE. So just understand, PPE, the last level of control, it's not the first. Just ranking it correctly. Lessons learned, I talked a little bit about that. So you guys are welcome to go through that, but effectively, it's the ability amongst the team when you finish a job to sit down and say, hey guys, what did we learn? We said we were going to do it this way. Did we do it this way? It became like this. It actually ended up, we did it like this because of these scenarios. How can we take what we learned and adapt our management system to prevent that risk from occurring again in the next job? And then there's things like stop cards. So in a lot of organizations, you have the ability within your team to say, hey guys, stop. Let's just think about what we're about to go into here, talk it through, agree that the risk is still within the matrix that we've allowed for, and then we go forward. Okay, so those are all the tools that you can add into your safety management system to take it. Benefits of an effective safety management system is improved safety. Obviously, regulatory compliance, you meet the criteria that you sit with or are working under. Cost saving, it actually saves a lot of money having an effective one because you're not dealing with incidents as much. You're not dealing with broken equipment. If you've got a lot of equipment failing on your jobs, you need to rethink, there's a possibility that we're doing it wrong, etc. And enhanced reputation. Your reputation increases because you're compliant, you're more structured in your approach, and you're executing correctly. Right, so how do we put all that into a management system? How does it really work? So if there's one thing I can ask you to remember today is LPPP. Okay, very simply LPPP. What does that mean? It's leadership, it's people, process, and plant. Okay, plant is equipment, basically. So it takes leadership, it takes people, it takes processes, and it takes plant and equipment to do something effectively. And that's the same with a safety management system. It's driven in exactly the same manner. And to break that down, leadership has to be committed on a non-negotiable basis to ensure that workers' safety is first. That's a non-negotiable. If it's not like that, stop. Change the leadership, because it won't work. Your safety management system will just not work. Occupational health and safety policy needs to be a framework of objectives, and it needs to be around effectiveness before efficiency. Don't jump to efficiency first. Deal with effectiveness first, and then put efficiency through the system. A lot of people jump to efficiency first and not actually deal with effective safety management systems. Very important. Responsibilities and authorities, people need to know what they're responsible for and what their authority is. Critical. If that's not the case, you can forget it. Consultation and participation with workers through lessons learned, through engagement with them to understand what they're dealing with and their frustrations, learning from those lessons, and adopting a human behavior principle from the leadership in terms of being able to work with your team to understand. A no-blame culture and an open discussion forums is critical to making a safety management system work. So that's the leadership criteria. Very important. There's lots more here. I'm just giving you the highlights. I can spend 2 days here talking about safety management system, but I'm just giving you the broad brush pictures here. People, resources, having enough resources to do it, critical. Competence, absolutely fundamentally the key part of what you're dealing with. If you don't have competence in your team, both in their skill set, their training, their understanding, the supervision, you're at risk. You're at serious risk. Awareness. People need to be aware of what your management system says they must do. They need to be aware of that and how to contribute to it. Effective communication, critical to establish that and understand that. And try and keep it as flat as you can. The flatter your communication level, the more effective you're sitting. If you've got a whole hierarchy of communication, you're going to end up with trouble in your management system. And then documentation, understanding that you can document records, document your processes, and so on. Okay, processes. They are basically through a risk assessment type approach, developing policies and procedures that are tailored to suit what you do and how you do it, including emergency response plans, and then trialing emergency response plans in everything you do. Establishing monitoring and reporting mechanisms, implementing training programs for your staff, increasing knowledge and competency, and then regular reviews. Plan, do, check, act. In the same way, you want to review your management system and see that you're effective in what you're doing. Plant, critical that you have the right people who maintain and operate your equipment. If you don't have that right person in place, rethink, because you're going to be at risk in your safety management system. Equipment should meet the regulations and standards and industry guidelines. So understanding that there are regulations, there are guidelines on how to do things, and you can use all of them. The tools are available, especially in the diving. There's a lot of available information and data for you to use. Technical procedures. It's not just about maintaining your equipment, it's how to operate it correctly. It's no use you have the best equipment out there and you're not operating it correctly. And that needs to be a competent operator with that understanding. And then the last one is an effective planned maintenance system and regular internal audits of your base or equipment. If if you're not doing at least once a year audit on your management systems equipment, you need to rethink. You need to engage yourself and with your team and say, hey, let's go and audit. And it can be an internal. You don't have to bring an external person in, but just audit it. Just adapt that culture of checking and learning and adapting to it. Right, clients, are you at risk? A lot of us as diving contractors and as you know, we have our clients, and all of you have some sort of engagement with clients. So what is the mix? Where do the two mix up? You know, how do we engage with our clients, and how do our clients engage with us? So client responsibilities are quite clear in our Occupational Health and Safety Act, in our diving regulations and so on. But in a picture, this shows you the picture of what it looks like. Clients need to tell the diving contractor what the hazards are. They need to say, hey, it's my piece of equipment, or it's my plant, or it's my dam, or whatever. These are the hazards. I think there's a suction pipe over here, or I think there's an intake for a water supply, and I think it's 20,000 liters a second. So it's significant. So that you know, these are the hazards that are involved in the ship, or whatever the case may be. Or I've got a massive propeller at the back, and I've got 3 thrusters in the front, and I've got this and this on the vessel. Then they need to lock out and tag out those hazards. It's their responsibility to have procedures in place to lock out and tag out that equipment, which means that they must isolate those hazards when we are working on them. Now, critical function that, some people are competent to do that from a client, and some people are not. And sometimes the diving contractor has to recognize whether there's competence there or not, and if there's not, we have to stop. So that's something we, as a diving contractor, have to look at, because I don't want to go and do an operation or a dive operation where the people cannot lock out or tag out their equipment properly or isolate. Appointments, they need to appoint the correct people in competence to do those sort of functions. And then on the diving contractor side, we need to go and have a look. So it's basically clients saying what they see, and then we have to go and verify it. We've got to go and have a look and say, yes, we agree with you or not. And then once we've done that, we put the right people in place, we put the right procedures in place, and we make sure we can lock out those hazards as they're indicated. And the relationship between the two is a client representative and our supervisor. Our diving supervisor would then be those points of contact in that job. So that takes various forms, but that's the relationship that you sit with in a safety management system that works with a client and understands those risks. The last one is a management system certification. So if you want to go to a certification level with a management system, an effective one, the ISO 45001 is a typical route that companies take, and that allows you to have an audited, systematic approach to your safety management system. And then it allows you to have someone actually come in from the outside, from industry, and look at your management system and say, hey, we think you've got some gaps here. We think you're not really effective in these areas. You need that outside perspective to really engage with your management system to make sure it's an effective system all the way through. And we use DNV, which is a marine-based auditing company, Detnos Veritas, and they're very effective in how they approach their system. I have a small video to show you. It just shows you the environment we work in. This is offshore South Africa, Petro SA, one of the last work scopes we did a couple of years back. This is a saturation diving system. It operates at close to 300 meters of water depth. So those divers that you see there that are working on the subsea manifolds, they'll be operating, I think they're operating about 160 meters water depth. They're running on gas reclaim systems, and you can see the vessel layout that you see there. That vessel is greater than 500 tons, just that you referenced yesterday's conversation. And that's fitted out with, that whole deck there is basically diving equipment. All of that equipment there, there's ROVs on board, there's air diving systems, and there's a saturation dive system. So just have a look, and we can talk about it later. Thank you. If you can play. Okay, so that's just a quick snippet of what we get up to. But as you can see, a robust safety management system is the only way to go forward in this type of work scope. Thank you very much. I appreciate it.
Yeah, thank you, Mr. Essop, for that presentation. It was interesting to hear the 6 months of planning just for 1 week of operation. I suppose it comes down to that saying of, if you fail to plan, you plan to fail, right? And thanks for touching on, we're reiterating yesterday what the Chief Inspector and Ms. Huna said about management systems and hidden costs as well as direct costs. Okay, so on with that, we're going to be moving on to our next presenter. He is in the UK, so he'll be connecting and presenting virtually. His name is Phil Crombie. We'll get him up shortly. But just a bit of background about Phil. So Phil has worked for the UK government. He's a H&M inspector of health and safety for nearly 34 years, starting in 1991 as an engineering sector and moving to the construction sector, railways, and finally the diving division in 2002. He is a qualified offshore surface supply diver, PADI instructor at a IANTD, Trimix, and rebreather diver. Mr. Crombie has always worked closely with the Chief Inspector of Diving, I take it that's probably in the UK, and overseeing the HSC diver training scheme and national and international liaison on diver training and certification. Are we winning with connecting Phil? Okay.
Yeah, I'm here. Can you hear me?
Phil, can you hear us?
Really good. Yes, I can, yeah.
Okay.
Can you hear me?
Yes, we can, Phil, yes. We just can't see you yet.
Good.
Yeah.
Okay, well, I can see myself on the screen.
Okay, there we go, yeah. If you want to share your presentation for us.
Yeah, I'll do my best. Hold on a sec.
So pity you couldn't join us in sunny Cape Town, but we do understand. Yeah.
My wife's had to scrape the frost off her car this morning, so... Can you see that?
Yes, we can. So yeah, thank you very much. If you can then go ahead with your presentation. Thank you.
Okay, so yeah, it was a bit of a strange topic for me to do, really, because I've not really thought that much about this. It was a bit like being given a school essay, you know, the evolution of commercial diving safety, trends and innovations. Not necessarily something, you know, I'm not a historian or anything like that, but I've used a little bit of history to look at trends and innovations, looking backwards in order to look forwards, I suppose. So a bit of North Sea history. In September 1965, the drilling rig Sea Gem found the first economically viable oil reserves in the UK sector, and unfortunately later that year collapsed with the loss of 13 lives, and a diver died during the salvage work on that. In 1967 was the first British diver dying whilst diving on an offshore installation in the Norwegian sector. And in February 1971 was the first offshore oil and gas diving fatality in the UK sector. So not a very happy start. And it continued. There were 54 fatal diving accidents just in the North Sea between 1967 and 1984. The worst single year was 1974 with 10 fatalities. And then we had a good period after that, 11 years with no fatalities. And then there's been a few more further deaths since then, as you can see. But overall, quite a significant reduction from 1974 onwards in the fatal accident rate. And you can ask, well, why were fatalities so high? Certainly, there was no regulation at all. There was no diver training. There were no diver commercial diving qualifications. There was a lot of use of scuba to do offshore work. And there was some, when you look back at them, and I have got a list of all of the incidents, including the reasons, that there were significant equipment failures, including, people dying from hypothermia due to the bell being lost, rapid decompression, including bells surfacing unintentionally, and there were cutting and burning incidents, and then the usual scuba, people getting tangled up or just never being seen again, having gone off to do their work. So what changed? Well, regulations, and actually what I have forgotten to mention was that in 1974 was the Health and Safety at Work Act, which still our primary legislation now, 50 years later, as you can see in my the slide background there. So 1974 was the Health and Safety at Work Act, and that resulted in HSE coming into being, and the general duties of doing all that is reasonably practicable to protect your employees, and also from self-employed to protect themselves, and even duties to protect members of the public from the work that you're doing. But we also, for the Health and Safety at Work Act, allowed for specific legislation for very high risk activities, and obviously diving is one of those. And so we had more prescriptive regulations specifically aimed at diving, and they came in 1981, the Diving Operations at Work regulations. Because they were prescriptive, they had their own challenges. It was difficult to apply these regulations for example, to recreational at work diving, because we cover all diving at work, including recreational instructors and guides. And so we had this more goal-setting set of regulations, which was the Diving at Work Regulations 1997, which we are still enforcing to this day. They're much more goal-setting. They require a risk assessment to be carried out for all diving work, and they lay out the responsibilities of the client, of the diving contractor, of the supervisor, and of the diver. In addition, the other thing that changed was the training. The Underwater Centre at Fort William was set up back in those early days to provide formal training, and then other dive schools came along as well. There were significant improvements in equipment, and there were medical requirements for divers. You had to be passed as medically fit by a doctor that had been trained in underwater medicine. And then we mustn't take away the industry input as well. The IMCA, basically, I don't know exactly the history of IMCA, but they clearly provide a lot of very good guidance. And industry itself, I think nobody really wants to hurt people at work, and industry have done a lot to improve things. Okay, so our goal-setting regulations were supported by 5 approved codes of practice, because we found that people still did really people like a bit of prescriptive advice, if you like. And so we've ended up with 5 different approved codes of practice. Originally, it was considered maybe we'd go for 2, one for scuba diving, one for surface applied diving. But then you've got these niches that, no, we can't work like that. We need our own guidance on how we can comply with the law. So we've got our 5 approved codes of practices: the offshore, inland, inshore, which applies to all sorts, the inland, including swimming pools and fish farms and the usual, what you'd normally imagine to be construction work in docks and so on. And you've got media diving projects, which is hopefully self-explanatory, the scientists and archaeologists, and then the recreational, I should say, at-work diving projects. So that's where anybody in the water is being paid to be there. And then separately, the police, under the Home Office, they develop their own approved code of practice for police diving projects. So as this is about innovation and development, I should let you know that they were all updated in 2014, all of those ACOPs. And that was to keep up to date with changes in thinking. and also to try and align ourselves in some ways with Norwegian regulations, particularly with regards to the partial pressure limits that we put on oxygen. The biggest change, apart from the time to chambers, which is a very tricky issue in the UK, and fitness to dive education information, the biggest change was probably on the dive team. So our previous ACOP had always required inland inshore for surface applied diving a minimum team size of 4 people. So that was the diver, the supervisor, the standby diver, and the tender. Now, all very well having 4 people, but a lot of risk assessments that contractors were doing saying actually we need 5, because if there is an emergency, one tender cannot recover 2 divers, launch the standby diver, hold on to 2 umbilicals, all that stress and so on. So a lot of risk assessments were saying we need 5 on site, but the clients who were paying the money were referring back to the ACOP saying, look, it says here you only need 4 people, so we're only paying for 4 people. So it was actually the Inland Inshore Association, the Association of Diving Contractors, that put pressure on HSE to change that. And so now, as of 2014, the minimum team size for surface applied diving is 5 people, and the minimum team size for a scuba dive is 4 people. So that is supervisor, diver, standby diver, and 2 tenders, 1 for each diver. Okay. Okay, and over the years, certainly since I've been in the diving group, HSE's really focused on the client awareness and duties. This has been a real success story, follow the money, and actually rather than running around chasing diving contractors, go to the clients, because they've got the most control in the fact that they decide how the work's done, what money is allocated to that project, the competence of the people involved in that project, and so on. And so we've developed this offshore duty holder diving management review process that we carry out for every single oil and gas client that works in the North Sea in the UK sector. And what this means is that every 5 years they have an inspection, and this is a very, very detailed inspection. We provide them with a set of questions as to how they control diving activities on their assets. We want to know what their management system is, the competency system that they've got for the staff, including their own in-house diving expertise, and if they haven't got in-house diving expertise, how they choose a competent contractor to carry that out. And they're getting used to this now, because they have to provide us with an evidence pack, so they have to show previous jobs, examples of how they've controlled the work and managed the work, even down to, right, it says here that you'll do a toolbox talk every day. Please send us evidence from the last job, attendee notes and so on for your toolbox talks. So we normally have about 2 or 3 inspectors spending at least a week poring over all this paperwork that they provide us, the evidence that they provide us, and then we arrange a meeting with them to go over the findings, to point out any weaknesses, and also to congratulate them on any strengths, hopefully. So this ODDMR process has been, as I said, has been a success story. One of the early success stories, I mean, most of the companies are getting used to it now because it's been going for about 15 years. So some people are on to their 3rd ODDMR review. But, an early success was making sure that there was time in the contracts for diver rescue drills. So the client, it can't just expect the job to launch into straight into work without them having evidence that they've carried out some standby rescue drills. Other ones have involved competence. We've certainly been concentrating on competence of the client rep and what their process is for that. Inland inshore, we've recently started a program for offshore energy companies. Same sort of thing, a similar sort of review process. How are these offshore wind farms choosing competent contractors, and how are they managing diving projects? And another recent big success was fish farms. For years, inspectors have been chasing around small contractors, insisting that they use surface supplied diving equipment rather than scuba when diving in nets and under nets, and removing morts and so on from fish farms. And we were chasing our tail, really, because there's always another contractor that's going to come along and provide a cheaper quote and do the work on scuba. And the big success story has been actually to find out who owns these wind farms, go and see them, make them understand that they've got legal duties. And actually, these companies are massive. They are huge. They can afford it. They can definitely afford for a 5-man surface supplied dive team to go and deal with their nets. And that's been a great success story as well. What else is there? Harbour masters, obviously, similar sort of thing. You know, do you know what diving's going on in your harbour? Have you got any process, any sort of permit to work? Are you checking anything from the, and some of these harbour masters are great. They let us know when work's going ahead. They want to know if the diving contractor is notified to us, and so on. So, yeah, there's a few topics, obviously, that I've just mentioned, and the success stories. Yeah, I think that's enough. That. So the obvious one, equipment. As you know, as I said, I was sort of trying to write this essay, thinking, well, what has changed? You know, well, some of the equipment has really improved. For commercial scuba now, we wouldn't expect ever to see any commercial scuba going on without, and this is obviously for, you know, lightweight, clear water, media projects or scientific projects. We'd expect them to have full face masks, communications aligned to the surface, bailout cylinder with the full face mask and a switch block. And we have had some issues with switch blocks because people are adding them in and not realizing how some of the, certainly we had a few in the UK that had never been tested to our European standard for breathing equipment, and we're actually restricting the flow. But there are now some very good switch blocks on the market that have, you know, they're CE marked, they comply. They're not going to mean that you can't breathe when you're deep. And yeah, so there you go. I hope that you'll all agree you should never really see scuba diving without a bailout cylinder. Everybody says, oh yeah, but we've got the buddy system. Well, that's, you know, these things start going wrong when you read the statement at the end of the day and it's the last time I saw my buddy, he was swimming off. Or I turned around and I couldn't see my buddy, etc. New equipment. This is just off the top of my head. I was just thinking, well, what else have we seen? Well, obviously, we've got the Cobra rebreather offshore, which has meant longer bailout duration if you do need to get back to the bell in a hurry. This was a fairly new one to me in the middle, the Wendell oxygen rebreather set. We've got this issue in the UK. Some of the diving contractors work a long way away from their nominated chamber. Now, if they have a minor bend or a suspected bend or something that's really not super serious, you know, slightly hurty elbow, they're not going to get an ambulance to transport them to a hospital or to the chamber. And so some of these chambers might be 4 or 5 hours away from where they're working. They need enough oxygen to get them there. So this little 2-litre oxygen cylinder can give a single diver up to 7 hours of oxygen. So a great innovation, and saves transporting loads of oxygen around with you. Sorry about the image on the right. It's really not clear, but actually that's an acoustic diver location tracking device. Again, another innovation. This was demonstrated to us a recent divers meeting by an archaeologist, actually, by an archaeological diving contractor. They use these on their divers. They can monitor up to 9 divers at a time. And for them, this is absolutely brilliant because it means they can map out where the divers are, send them to different bits of, say, a wreck or whatever it is that they're exposing in possibly very poor visibility. And it's got definitely safety benefits as well. We've had a contractor who wants to have basically trying out military underwater vehicles, which mean basically they're traveling very rapidly underwater in a submersible vehicle. And our concern was, well, how are you going to find a diver if they bail out of the vehicle and have a problem because they've got no line to the surface? And actually, this is one of the solutions, an acoustic diver tracking system. Another one, certainly with our police forces, lightweight surface supply. When they've got to go and search a lock or a pond or whatever that's actually very difficult to get to, they can't get all the equipment there. They certainly can't get a surface supply panel and all the rest of it rapidly. They can use this. It's an Inspiro DP1. Sorry, shouldn't be advertising, but it's very lightweight surface supply system. Kevlar cylinders. You can carry, one person can carry 4 of those 300 bar cylinders without too much difficulty. A 75 meter umbilical that you can stick under your arm, and you can see there how small the panel is. That is basically just for one diver. You attach, the reason there's 2 hoses is obviously you want 2 cylinders attached at one time. Once the cylinder runs low, you switch across to the other cylinder and so on. You can just keep going like that, swapping cylinders out. But an improvement over using scuba. I was trying to think, well, what else has changed? What other innovations have there been? And actually, some of them are just very small improvements to diving equipment. Can't hear you, so I won't ask you to shout out, but one of the very first fatalities that I looked at when I came to HSE was a band mask falling off. And so, the design of that band mask has been improved so that you've now got the Kirby Morgan band mask keeper, 2 physical attachments to the band mask, so it can't fall off. That was an easy design improvement and, has improved safety. And then even the very little things on the right there, you've got the pull pin sleeve kit, again, an improvement provided as an upgrade by Kirby Morgan. And it's to prevent that pull pin being snagged on a bit of rope or anything and being inadvertently opened on the helmet. So it's just a simple, really simple thing, just a conical piece of plastic that fits over the top, and it prevents snagging. So I had to rack my brains. Oh God, the cat's just brought a mouse in. Anyway, shut up. Right. Oh, and it's still alive. Oh, great. Okay. Right. Sorry, I'll try and concentrate on this. Other innovations. Computer-controlled systems, which you can argue are a benefit. IT, such as, when I joined HSE, there was no such thing as a computer on your desk, but IT, so you can now have good management of your planned maintenance systems. Heads-up displays, certainly the military use them on their scuba sets to warn of, once their one cylinder gets down to 60 bar, on comes the light, switch to your bailout and surface. Telemedicine advances, instant access using the internet and so on to design and technical manuals. Mobile phones, we never had those, in the case of an emergency. And internet shopping, which you might laugh, how is that an innovation? But actually it has caused problems in the fact that there are some very dubious things you can buy on the internet, including your own pump-up diving cylinders, your battery-powered hooker systems. Certainly not CE marked, never tested. Yeah, very dubious, but unfortunately you can get them. We've asked them to be taken off places like Amazon and so on. They get taken off, and before you know it, they're back on there again. Somebody else is selling them. Likewise, HUDs, you know, I know of a diving incident that happened with the MOD that definitely happened, or certainly the heads-up display contributed, because their eye had been taken off the ball with regards to gas calculations. They'd actually removed the gas calculations part of their training for supervisors because of the HUD. And yeah, a diver died as a result. He was ignoring his HUD because he was task focused. Likewise, rebreathers, certainly a huge innovation with recreational diving. But when you look at the number of incidents on rebreathers versus the ownership, you know, has that been a good thing? A quick look at our British Sub-Aqua Club annual statistics shows that, you know, there's been around 10% of recreational diving fatalities are using rebreathers, but ownership is certainly nothing like 10%, which causes concerns. And similarly, computer controls, computer-controlled diving equipment. When we look at our reportable dangerous occurrences offshore, there's quite a few, you know, malfunctioning. I'm just looking at them now. Malfunctioning valve, allowing more gas to pass and vent than expected. An ECU sensor failing resulted in pressure loss. Servo motor failed during decompression and the unintended depth change. So whilst these computer control systems are there to make our life easier, they are a little more complex, and I'm not sure if they add to safety or just cause us more problems. And then you've got the innovations versus absolute recklessness, and this was a fatality that we investigated a few years ago now, back in Wales, where a guy was collecting golf balls using this equipment, and you may be looking at that equipment thinking, well, what on earth is it? Well, on the left, there's a rubber ring that would normally be pulled along for fun behind a speedboat. In the middle of that rubber ring is a builder's bucket with a bit of plywood on top. Mounted on the top of the plywood is an electric pump of no specification, certainly. Amazing, actually, that he survived for 2 hours before drowning, collecting golf balls, and he'd collected an awful lot of them. But underneath that, in that builder's bucket, is like a leather bag with a car battery in it, with a couple of clips on the car battery, providing that pump with power. So there's nothing innovation will do to stop downright stupidity. And likewise, have we really improved? I mean, I just got this from the worldwide diving fatalities. Tim Cheshire, I don't know if you're aware of him, but he's almost got a hobby, if you like, of collecting data from news articles and so on all over the world on commercial diving fatalities. And you can see from those figures, well, has there really been much of a change? I'd really like to think that that massive decline from 2010, 2011 down to 2022, wouldn't it be great if it stayed down at the 2022 levels? But I'm not sure it will. Okay, so that's a quick run through from me, just trends and innovations. I hope you found it interesting, and let me know if you've got any questions.
Okay, thank you, Phil. We can give him a round of applause, please. We want to put Phil back so we can see him again. Yeah, I saw a meme the other day saying cats are one of the biggest disruptions to online virtual meetings. So It's a pity we couldn't see you, otherwise you would have added to one of those videos on YouTube.
Yeah, I was a bit distracted, but the cat is still
yeah,
hunting for his mouse.
So we're going to do a quick question and answer session for the two presentations we've had in the morning. So can I see by hands if there's any questions for both Mike on his presentation and Phil on his? No one need more clarity on health and safety management systems? I think you can see from Phil's presentation that a lot of our legislation and codes of practice are similar to what they got in the UK. We do need a basis for starting our legislation. So, yeah, that's kind of where we look at other countries and internationally, and then obviously adapt it to South Africa. Yeah. So, yeah, I think also with the evolution of the equipment, it's similar to the regulations in that, yeah, we learn from previous fatalities, previous incidents, and obviously then have to adapt legislation accordingly. We always have that saying that legislation is written in blood, obviously for a specific reason. Okay, so we got one question. Again, yesterday, if you can please stand and just say who you are and maybe who your question is addressed to as well.
Yeah, thanks. Azwimba bin Ramondo, South African Maritime Safety Authority. I think, I'm not sure if it's a question, but a comment to Phil Crombie. Didn't note down the slide. I think he spoke about the audit of the service recipient in diving some way, and I'm just very curious about how that actually works in terms of. Yesterday we spoke about vessel certification in relation to the 2023 IMO code, or IMO diving code. And there is work being done in South Africa to talk about how that code should be given effect, if at all. And I'm wondering how that code would then apply, say, to somebody who's receiving the service from somebody who's approved, or a vessel that is certificated in terms of the 2023 IMO code, and what kind of legislation is in place, what kind of systems did you have to put in place for that, what you term client awareness and duties. Thank you.
Phil, did you hear that?
Yeah, yeah, I did. Yeah, so we've got we have got marine specialists in HSE and we have got one section of our ODDMR. One of the questions is with regards to vessel suitability. We're diving specialists, not marine specialists, so we rely on our colleagues if there's anything particular that concerns us. But we certainly look at the duty holders' management of how they ensure they've got a safe vessel. And it depends, of course, on how their diving's done. But, you know, we've got both installation-based diving and vessel-based diving. Most people nowadays use a vessel. And it'll be more of a higher level as to how they ensure that the vessel is appropriate for the diving. What I can do is I can send Jabu our question set that we use for the ODDMR. It's certainly not private, and I'm happy to share that, and then she can send it out with the notes of the conference.
Okay, thank you for that, Phil. Any other questions? If there's none, I got one for Mike in terms of his management system. Maybe, Mike, if you can explain, how long did it take you to get to where you are now in terms of that system? Was it a short period? Did it take a while? Obviously, there was improvements on it. If you can maybe just elaborate on that a bit for us.
Hi, everybody. Yeah. So, first of all, it's never finished. It's always a work in progress, and it's always a learning opportunity as you go through each year and you look at the jobs that you do and so on. But in terms of the initial implementation, it took us, I would say, about 3 years to fully implement an effective management system. And then it's taken us another 4 or 5 years to pull the efficiency through the system to make it efficient and fast and pull that through. So, yeah, it's a few years to get there. But, yeah, certainly within the first 3-4 months, we saw significant change in our team and in our processes and our results. So it wasn't too long before we had some good results coming through. But yeah, it is it's a change in your thinking, and it's a long-term goal to drive it through.
Thank you for that. I'm glad what you said at the start of that it's never finished, because we often tell employers in other sectors that health and safety, you never have a finish line. It's always going just further ahead. Once you think you got there, something else changes. So you never completed or complying completely with OHS in general. Thank you for that. We got a question in the front here. Peter? Okay.
Thanks. Bulelwa Wona, Department of Employment and Labour. I want to know, Mike, how do you maintain the interest of the divers to make sure that they are fully engaged in giving inputs into your system? Be it a little input, observations, or anything when with respect to the work they do, so that it improves your system. Thanks.
Okay, engagement with the divers, is that the correct question in terms of how it relates to the work being engaged? Yeah. So I think first of all, what we look at, we have standard procedures and methodologies that have been reviewed over the years. So we have a standard set of guidelines on how we operate and so on. But when it comes to the specific task, we do what they call task familiarization. And that task familiarization allows the divers to observe and run through the procedure and become acquainted as to what they are about to do. Obviously, that matches up to their training. That's great. If it doesn't, then we'll have to continue with further familiarization before they do that. So yeah, that's how we would typically handle it. On offshore work scopes, our clients allow us a bit more time to actually set up the exact example of what we're about to do underwater, and then we're able to do very much a walk through of the steps that need to take place underwater, and then the team sits and discusses it. We have engagement with the supervisor. The supervisor normally has the role to approve the procedures prior to it even getting to the job site, and our engineers are part of the team that actually builds and creates those pictograms and the procedures that go through it. So the competency is pulled through from that side, and then the guys who are actually doing the job, they walk through the procedures prior to us doing the work. Yeah. Yeah. And obviously that's known as toolbox talks as well. So that does the step-by-step prior to engagement, but in the bigger picture, you want the familiarization of the overall job, so everyone has a clear idea of what they're about to do.
Yeah, thank you.
Yeah, JSAs, there's a lot of terms that we can use.
All right, yeah, thanks, thank you. Okay, so I just see there's one more from Bulelwa, there's Clement, and also Dr. Mankey's at the back.
Okay, thanks, Mike. This one is for Phil. Hi, Phil, if you can see me.
No, I can't see you, but carry on.
Yeah. I want to know, how long does it take for you if you've noted a non-compliance with a duty holder or a contractor, and you have to refer for prosecution? How long do your processes take?
Depends which processes. I mean, we've got immediate prohibition notice, obviously. So if there's risk, I'm sure you've got exactly the same. If there's any risk of serious personal injury, in the inspector's opinion, doesn't even have to be a breach of the law, then we can just stop the job, depending on what it is, you know. And then we've got something called an improvement notice, where there does have to be a breach of the law. So, for example, if we went to a dive site, there's no toilets and washing facilities, as an example. Depending on the situation, you could argue, I mean, there's still arguments to say you could stop the job, but you decided that there wasn't an immediate risk, say there's a pub down the road they can use to wash their hands and go to the toilet, and you'd give them 21 days to put that right. And then if they were a repeat offender, or if it was something very serious, then obviously we can prosecute them. Now that takes a long time. As soon as you get the lawyers involved, that can take years. And we've got fatalities still open that are 3 years old, which is, you know, not desirable for any of the people involved. But unfortunately, that's just the system, and you have to play the system.
Yeah, thanks for that, Phil. It sounds like we are very, very similar in terms of both of our legislations and our processes that we follow. But yeah, thanks for sharing that from the UK side. Okay, next question from Clement.
Good morning, Clement Lekheto, Department of Labor. I wanted to check, Mr. Yesop, with regards to having the no-blame culture, where do you draw the line between holding people accountable and also having a no-blame culture with regards to violations or non-compliance with the management system? Thank you.
Mr. Yesop needs a mic.
Right, to find a mic. Yeah, that's a very common question, is how do you handle no-blame culture with some accountability? With tender gloves is the easiest answer. But so what we do is by having a no-blame culture, we are allowing our people to make mistakes and tell us about it. So we have, if you make a mistake and you tell us about it, that's the no-blame culture. If you make a mistake and don't tell us about it, well, then you're accountable. And so that becomes the differentiator, is we want to know when mistakes are made so we can deal with it, we can work with it, we can change systems, we can retrain the people. But as soon as you don't tell your management team or your supervisor or something, you become accountable and you're held accountable for that. So that's the difference, the primary difference. There are a number of little nuances that you can work around, but in a no-blame culture, it has to be that as a leadership and your management team to accept, to work with, and run through. If a person becomes untrainable, i.e. you train them and you train them again, well, then you have to look at competence. And then they must be treated as incompetent for that task. And then that's a different approach that you deal with. So that's how we work within the structure of a no-blame culture for human performance. Yeah. Cool.
Okay, thank you for that, Mr. Erfeld. Yeah, sounds like nice soft skills there you have in your management process. Dr. Mankies, if you can go ahead, please.
Thank you. And I've got a question for Mike, and it relates to the fact that health and safety is often almost seen as a grudge payment, and something that you have to do. But in your case, you're talking about a management system that you've got in place and that management is actively engaged in this. Have you got some pointers in terms of the financial benefits of such a system and whether it actually makes a business sense to work towards healthy and safe? Is it simply just a reputational risk, or is there some real financial benefits for a company investing in their employees and so forth?
Also a very good question. Yeah, in our space, in the offshore oil and gas space, in the energy space, it's non-negotiable. So if you want to work in that environment, you have to have an effective and efficient safety management system. It's not something you cannot not have that. So from a financial perspective, in order for us to work in that environment, we need to have an effective system that gives us that thing. But in doing so, we've found the benefit of it. It actually makes our life as leadership a lot easier. Engagement with our staff is fantastic. Yes, it's a lot of paperwork, but with the IT solutions and information management systems out there nowadays, you can make very light work of the compliance requirements. If you want to engage in that, I mean, we create reams of paperwork for any one single job, but at a push of a button, we can create it. And we allow our staff to sign off on a digital basis, because that's what the legal frameworks allow these days. It's fantastic. It's a lot quicker, it's actually very simple, and we're very compliant in that regard. And then creating a no-blame culture actually opens up the organization to learning. And you allow your staff from the coalface to tell you what's going on, you adapt to suit that, and it drives it forward. So yeah, it is beneficial to the organization. It does definitely have a reputational benefit, but I think the singular change is that we're listening to the team on the ground, and we're able to drive our business through that feedback. And yeah, we're able to achieve work scopes that we were never able to achieve before in the oil and gas space.
Thank you for that, Mr. Gray. Perspective. Okay, question from the captain, please.
Good morning or good evening. I don't know the time there, Phil, and good luck with the cat. And I'm Captain Sutton from Water Policing and Diving Services in South Africa. We've got similar legislation towards certain matters that's also from the British side of the law. One of the things that we studied a bit about was your approved code of practice for police diving projects. I think that project was signed off in 14 March 1999, and it is available on the internet. I just wanted to confirm if that code is still maintained, or was it updated or changed by any a newer version of it? That's my first question.
Okay, well, I can answer that fairly easily. So the Home Office, when we came to reviewing our ACOPs, the police diving ACOP was a Home Office document, and nobody could ever find any records of it ever being signed off. So that was an interesting start. So what the police decided to do was do away with their ACOP, but they wrote a new set of police diving rules. And they based those diving rules on the inland inshore ACOP. And we checked their police diving rules to make sure they were the same standard as the inland inshore ACOP or better. And actually they have gold-plated it in places. So they have a minimum team size of 6 for surface applied diving, whereas the ACOP has 5, you know. And that's the obvious example I can think of. But no, there is no ACOP anymore. It's police diving rules, which they own themselves, and they get updated from time to time.
Okay. I remember vividly that when I started in the diving industry as a young police diver, that if I look at this document, even in our occupational health and safety side for inshore and diving inland, was very similar to what I read still here today. Also in reference on page 14 on that document, which is not in front of you, but it is exactly a blueprint of how we dived and still are diving on most of our scenes today on scuba. The processes is exactly the same as the way that we contract with our different police stations to recover bodies in dams or on certain spots is very similar diving techniques used from as early as 1976. So our working environment is obviously different from the commercial industry, but the body recovery still seems to be the same as the code, and it's definitely something to consider with the current changes within the commercial diving environment with us as well going forward. But it's actually a blueprint of what we still do today.
Yeah. I mean, none of our police forces use scuba anymore because there's just no need really with the DP1 system. You know, it's Arga mask, very, very lightweight umbilical, same sort of size as a lifeline, you know. So, and because a lot of our diving is done in zero visibility, you know, you imagine if, I don't know if you've ever been to the River Thames, but it is dark, you know, very dark water. You're going to have absolutely no visibility. And so you just don't know what you're swimming into. And they found, even using their DP1, that they've been in that sort of situation and realised that the umbilical was snagging, and then they discovered that they're actually in a huge coil of wire that's been chucked over the side of a boat. And they, you know, and you imagine if that was just on scuba and you did get trapped, you haven't necessarily got the time to sort it out.
Yeah, no, it's noted. I think in comparison with us, we average just in the Western Cape approximately 133 bodies per year, and it can go up to 200, 250. That's only for one province. So we're dealing with a total different environment and challenges. We have crocodiles and strange things that swimming with you in our water conditions. So it's difficult to negotiate with a hippopotamus while running and somebody shooting the thing. So we also have our challenges, but I think each to their own, that the environments do different, but there must be a midway that we can find each other on this. Thank you for your time. Thank you.
Yeah, you're welcome.
Thank you for that. Any last questions for the session? Okay, last one at the back, please. Or midway.
Good morning, everyone. Morning, everyone. My name is Kaya from the Institute for Maritime Technology. My question basically is towards for Mike. I see we put a lot of emphasis on health and safety. So within OSC Marine, what measures do you have in place to prevent the negative effects towards the environment that your company might be exposed to? Not that health and safety is a bad thing, but what systems do you have in place, considering that you guys are also certified with ISO 5001?
Mike, please. Mike, please.
Sorry, just to understand the question, it's what systems? Regarding 9001. Okay, so 9001 is the quality management system, compliance, yeah? 14,001, okay. So on the environmental side, so for example, so that typically deals with, what are the potential hazards that we may have with respect to spills, dealing with spills, or dealing with environmental type scenarios where our work practices can influence the environment in some way. So for example, in our scenario, we would be using environmentally friendly hydraulics for our hydraulic tools. The oils that we use, if it does get severed or whatever, it doesn't affect the environment. So those are more expensive, but that's on us to ensure that that takes place. When we deal with underwater cutting, for example, if we're having to cut plastics, We have to take particular caution of how, what type of tools that we're using, so it doesn't create plastic burrs that go into the environment, to go into fish or whatever the case may be. So all of those things is what we would look at. But we'd assess that as a risk and look and see how that environmental impact is managed. So yeah, that's how we would typically go through it's very similar to safety. You'd look at a risk assessment. Environment, you do the same. You look at the risk assessment requirements. Yeah.
Okay. All right, thank you for the interaction, everyone. To Phil Online, thank you again for connecting and joining us. Hopefully next time you'll be able to be here in person and get you away from your cats and that frost. Just a quick reminder, everyone, the presentations will be available on the department's website at the end of a little bit of time after the conference, so you don't need to take photos. You will be notified and given the link to the presentations if you want them. So with that, it's now tea time. So tea time is scheduled to end at 11 o'clock. So if you can please be seated by 11 so we can continue with the rest of the program between then and lunchtime. But yeah, thank you. Okay. Oh, yeah, there's time for fishes and selfies and groupies later, so yeah, plenty of time. Are we back online as well? Okay. So up next, yeah, the session between tea and lunchtime, we're going to have some more specific diving related topics, and then we're getting onto some other aspects that are included in the bigger picture of occupational health and safety, but what is diving. So our next speaker is going to be doing 2 presentations. He has promised me that they're going to go very quickly and entertaining. A lot of videos and that. So his name is Bill Chilton. Bill joined IMCA in November 2021 as a technical advisor for diving and became the diving manager in January 2024. He has 25 years of experience in commercial diving industry. And prior to IMCA, Bill worked for the UK Health and Safety Executive, the HSE, for 12 years as a diving specialist inspector, regulating the safety of divers working in the offshore energy and other sectors of the diving industry. During this time at the HSE, Bill also worked as a decommissioning specialist when he was seconded for a period to a team specializing in decommissioning. Prior to his time at the HSE, Bill worked as an air and saturation diver on a wide range of diving products. During this period, he also held a variety of topside positions, including project engineer and project manager. Bill holds a BSc honors in geography and an MSc in marine resource management and an MSc in decommissioning. So, yeah, I think very experienced and very equipped to lead us with this hour of presentation. So I'd like everyone to just welcome Bill up to the stage. Thank you.
Well, thanks very much for those kind words. I'd just like to give a couple of shout outs and thank yous. Firstly, to everyone here who has been so welcoming. It's my first time in your country and I've been made very, very, very welcome indeed. I'd also like to thank the DEL for inviting IMCA for this opportunity to come and present to you. And finally, the unsung heroes of events like these, the AV team at the background. They've done a phenomenal job at the dial-ins, the sound, the music, and as Warren mentioned, my presentation does have a number of videos, and I can assure you that we did a test run this morning and everything worked perfectly, so fingers crossed it will do for the real-life event. Yep, that's my introduction. As you can see, I've got a fair bit of experience in the diving industry. As I originally wanted to be a marine biologist, but wasn't very good at it, having an event in Aquarium is absolutely perfect. So again, thank you very much for sorting that out. My presentations have been lumped together now. So my first one was going to be looking at emergency procedures and what happens when things go wrong. And my second one is going to be looking at the time I spent with the health and safety executive and looking at a fatality and a serious offshore incident that I had to investigate. And I'll hopefully impart some lessons learned about those. Just a little bit about IMCA. Phil Crombie, the HSE inspector, said he didn't really know the history of IMCA. But what happened was in the 1970s and 80s in the offshore North Sea, we were killing a diver a month. So before there was any regulation whatsoever, industry came together and decided, what are we going to do to stop this? And IMCA was formed all those years ago. Warren mentioned that every piece of diving regulation is written in blood, and that's true for pretty much every IMCA diving document. There are 84 diving documents now, and the majority of them have been written because some diver has unfortunately died. This topic, I was asked to talk about diving emergencies, and I realized that's such a big sector to cover. We've got saturation diving, shellfish diving, TUP diving, surface diving, scuba diving. I thought there's no way I can do justice to that in half an hour. So what I would like to do is look at the one sector that kills more divers than any other, which is underwater ship husbandry. Now, for those of you who don't know, this is the maintenance and repair of vessels underwater. We know of 30 diving fatalities in the last 2 years on underwater ship husbandry projects. I suspect that figure is almost double that. They're just not being reported. So what can we do about it? Well, this isn't core IMCA business, but we do have IMCA members that have lots of vessels. We have a marine section, and sometimes they will require maintenance on their boats when they come into harbour. There are strict cleaning regulations when you take your boats to ports in Australia or Brazil, so hulls have to be cleaned to a specified standard. Also, there might be ropes, nets, or fishing gear wrapped around the propellers that require urgent intervention. So we originally wrote this document for our members. It's D082, and as I mentioned yesterday, because there was such interest in this and we felt that we could actually do something for the greater good of the commercial diving industry, unusually for IMCA, we have made this document free issue, so anyone in the world can go to our website and download it. You don't have to be a member of IMCA. We have been looking at keywords, and Mike used the phrase PPP in his presentation. When I worked at the HSE, I quite often had new diving inspectors that I need to train up. And sometimes they were a bit overwhelmed with the amount of information, regulations, and guidance that they had to store in their heads for undertaking site inspections. So what we did was broke it down into PPE, which stands for people, paperwork, and equipment. And what I can assure you is in every single diving fatality or incident that I've investigated, one or more of these three things has failed. And I'm going to go into a bit more depth about them now. The people, again, Mike covered this. We're looking at competency. We're looking at training. We're looking even bigger picture than that. Are there enough people? The correct team size. As Phil mentioned, the diving at work regulations in the UK, the major revision went from 4 divers to 5 divers. What we typically see on underwater ship husbandry projects is their very last minute, the cheapest solution, run by people that don't know diving, so often you might get a 1-man team or a 2-man team to do the work, and that leads to problems. Qualifications is another area that IMCA has been focusing on. When we get a new diving company that wants to join IMCA, we do a very, very thorough audit of them. We probably spend a month just going through the safety management system and making sure that they can comply. But what we also do is make sure that the people are qualified. Now, we got an application last year from a company somewhere in the world, and this might be of particular interest to the inspection team here at DEL. We asked for the certificates of the divers. This is a UK HSE diving certificate. It was fake. So was this one. So was this one. So was this one. In order to ensure there is medical assistance on site and there are diving medical technicians, divers have to do a 2-week intensive course of theory and practicals in invasive medical techniques such as suturing, chest drains, and intubation. Life-saving critical skills. This diver medic ticket was fake. So was this one. Then perhaps most concerning of all, in order for divers to be able to inspect offshore installations like the one Mike showed you, which might have up to 200 people living on them, they need a specialist welding inspection qualification. This one was fake, as was this one. Every certification we got through the door that day was fake. So please be aware of that when you're verifying the competence of dive teams. Paperwork, the second of the P's. We've looked at the people. Now paperwork, lockout, tagout procedures in underwater ship husbandry. There have been instances where divers have been killed due to the activation of suction pumps or other machinery on vessels, which has pulled them in, trapped them, and due to the type of equipment they're going to be using, which I'll talk about later, it's ultimately led to their death. So lockout, tag out, vitally important, will save lives if done properly. Also on the equipment side is the type of tools that should be used to undertake underwater ship maintenance. We're talking here about blocking off inlet valves, outlet valves, or sea chests, the type of blanks that have been used. Now, people have been killed because they've used non-engineered solutions. And by that, I mean trying to block a suction valve with a timber bung, or trying to block a sea chest with a bit of Hessian sacking, something that hasn't been engineered, something that hasn't been tested, something that hasn't been proved and has ultimately failed. What a lot of more responsible shipping companies now are, when the vessel is built, they will actually have the blanks that needed for all of their sea chests and valves constructed at the same time and stored on board. So if they do have an emergency, the right tools are ready for them there to go. As I mentioned, we have had fatalities where timber bungs have failed. You can't really rate a timber bung, it can't be engineering proved. Once water in it gets in it, it gets weak, deteriorates. There are engineering solutions available, and every competent diving contractor worth their salt that undertakes this kind of work should carry some proven engineering solutions for this. Also talking about equipment, of those 30 diving fatalities I mentioned at the top of this presentation, 29 of them that we know about died using scuba equipment. And our co-organization, the Association Contractors, Diving Contractors International in the USA, put this handy animation together, which will hopefully play now.
Have you ever wondered how large an anchored ship looks to a scuba diver? Think of looking at Burj Khalifa or Marina Bay Sands from the ground level. That is what a 300-meter-long ship looks like to a scuba diver. The hull obstructs the diver's view, making it challenging for them to swim to the surface. Even if a diver's 20-meter-long dive support vessel is moored to the ship, without visual aids, a diver can lose their orientation. Surface supply diving allows the diver to follow his umbilical cord back to the dive support vessel. Surface supply diving allows the supervisor to control the dive, provide an infinite supply of breathing media to the diver, and allows the diver to reorient themselves in limited to no visibility environments. It also allows the standby diver direct access to the primary diver by tracing the primary diver's umbilical, thereby allowing topside a quicker response time to any in-water emergency experienced by the primary diver. Additionally, surface supply diving allows for hardwire communications between the supervisor and both the primary and standby divers. With surface-supplied equipment, the level of safety for underwater ship husbandry diving is substantially increased by mitigating the hazards associated with the use of scuba. Surface-supplied diving is the right mode of diving for underwater ship husbandry.
So what happens in the real world? Well, this next picture was from one of our members, and it's a very, very sophisticated diving support vessel. The dive team wasn't on board at the time. They were trying to get to a job. They got a rope around the propeller, so asked the shipping agent in the local country whether they could source a dive team to come and get it out for you. And this is what they were met with. 3 canoes, and as I keep going back to this acronym PPE, the people, no one was qualified. There wasn't a dressed standby diver, no system to put in some diver recovery, poor communication between the various canoes, paperwork, no equipment certification, divers weren't qualified, not medically fit to dive, and then finally the equipment, unmarked 50-litre cylinders, no certification, and hoses trailing in the water between them and the panel. But there's definitely a school of thought that thinks, well, this was in another part of the world where they don't have a robust regulatory system for diving. I live in the northeast of Scotland, where North Sea diving has been going on for about 50 years. A very, very robust regulatory framework, very competent diving contractors. But this happened not 20 miles away from where I live. This is one of the major ports in the northeast of Scotland, and again, fishing gear trapped in there. There was competent dive teams known to the harbour master that could be there on call, but what actually happened was a A Port Authority worker noticed a recreational scuba diver coming back and asked him, "Can you go and take that rope off our propeller, please?" So the scuba diver taped a knife to a broom handle, jumped over the side, and got to work. Nobody knew he was there, not the vessel master, no one on the vessel. This could have been a fatality less than 20 miles away from where I live, in arguably one of the most competent areas of diving in the world. So please, just don't think it can't happen here because we have a robust regulatory framework. So, summary, underwater ships husbandry, statistically, physically, the most dangerous form of commercial diving there is in the world at this moment. Most divers that died on these projects were wearing scuba, and in the event of a fatality, I guarantee you one of three things has failed, if not more: the people, the paperwork, or the equipment. And that's presentation number 1 done. How do you want to work this? Do you want questions on this, and then we go to the next one, or shall I just crack on and then do big Q&A at the end? Yeah. Yep, please. Okay, as I mentioned at the start, we're going to be looking at some of the incidents and lessons learned from my time with the UK HSE. Because I know there's a wide range of diving experience in the room here, I thought I would take them from different ends of the scale. The first one is going to be a shellfish diving fatality that I was involved in. And the second one is going to be a serious saturation diving incident which involved oxy-arc cutting on a structure in the North Sea. Might recognize this slide. I actually wrote it for the HSE before Phil Crombie stole it in his presentation. But UK HSE covers a wide range of diving types, and there was different ACOPs for each of those diving sectors. They go into a bit more detail about the prescriptive rules that you should follow to make sure you're compliant. As Phil mentioned, HSE does inspections, investigations, enforcements. I think one thing that's quite unique about the HSE, though, is when you join, you're given a warrant card, and you're also a public prosecutor under English law and under Scottish law. You build the case and give it to the public prosecutor, the procurator fiscal. So I have stood up in court, and I have prosecuted diving supervisors and diving companies. So this shellfish diving fatality, in the UK, certainly when I was with the HSE, this is the largest killer of divers. Legal background, this is what we would expect to be there. A 4-person team who have relevant diving qualifications and medical certificates of fitness to dive. We'd expect a level of commercial scuba, as Phil demonstrated in his presentation, and some degree of risk assessment. There's very good money in this sector. Hand dive scallops are seen as a delicacy. It's said that when they're hand dived, the scallop doesn't get stressed as it would when a dredger comes in, so actually the quality of the fish is much higher, and that means there's a premium. So this sector of the industry does attract a lot of people driven by money who might not have the requisite skills. And going back to my previous presentation, that legal background, again, can be summarized by the people, the paperwork, and the equipment. So in this particular incident, it was a 2-man team, and they went off to go scallop diving off an island off the north coast of Scotland. They were making their own nitrox, and when I did the investigation, I realized that these guys probably didn't have the requisite knowledge to blend their own nitrox. For the non-divers in the room, nitrox is a way of adding oxygen to air, which in certain depths can increase your bottom time. So when you're hunting scallops and you find a great patch, if you can stay down for 10 or 15 minutes longer, it can have a huge impact on the amount of money you can make. However, get the blend wrong, and you could go into oxygen toxicity, which is effectively an epileptic fit underwater, go unconscious, and if you're wearing recreational scuba, the regulator will come out of your mouth and you'll drown and die. So in this particular incident, a 2-man team. They had both done 2 very deep dives for scallop diving in about the 30-meter range. One of the divers was didn't come back. His buddy on the boat noticed a big rush of bubbles and then nothing. Because his buddy had already done 2 deep dives, he had a lot of nitrogen in his system. If he went diving again, it's highly probable he would have suffered decompression illness and needed to be treated for that in a chamber. It took 6 months for the body to be recovered, and as I'm sure you know, if a body's been underwater for that amount of time, it's very difficult to undertake a post-mortem with cause of death. One of the questions that DEL asked on Phil's presentation was, how long does your investigations take to go from initial investigation to prosecution? This was mine. It took pretty much my entire career at HSE. It took 9 years to get this one over the line. There were lots of problems with it. Because the body was in such an advanced stage of decomposition, we couldn't prove what went wrong with it, and then there was lots of other legal issues that were thrown up. So it did take a long time to get there. So again, going back to my PPE, what went wrong? Well, only having 2 divers for a start. It meant when the diver got into trouble, no one could rescue him because the other diver had high nitrogen loading. They weren't qualified. The diver that died had never had any diver training at all. He just thought, this looks like a way to make a quick buck. I'm going to give it a go. No certificate of medical fitness to dive. When I was running the investigation, the witness statement from the diver that survived said that the diver that died after the first 2 dives was coughing up blood and blowing blood out of his nose after those 2 dives. A doctor would have picked up that there was something wrong and probably not allowed him to dive. Sorry. I mentioned about the nitrox. So again, I'm not sure whether they were qualified. Well, they definitely weren't qualified, but there were serious risks of blending own nitrox. There are physiological impacts, such as I mentioned earlier. The paperwork, well, to be blunt, there was nothing. There was no risk assessment, there was no qualifications, there was absolutely nothing at all there. No dive plan, no emergency procedures, no equipment certification, and it was a disaster waiting to happen. Someone was always going to get hurt on this project. The equipment, this gets better now. Recreational scuba, as we've discussed, but this was bought on eBay, not certified because it was cheap. Equipment not certified, obviously buying on eBay isn't really the way to go. As I've mentioned, neither of the guys were qualified, so they didn't actually know how to set it up properly. When our laboratory got hold of it, it found out that there were significant failings with the rate of breathing of the regulators. When you're using enriched air nitrox, you have to transfer oxygen. Now, oxygen is a very reactive gas, and at dive school, we're all taught that you introduce it very, very slowly via a needle valve, because oxygen will react with bits of tape or rust or any other foreign bodies in the line, and this can result in a very catastrophic, very high temperature oxygen fire explosion. People have died from this. These guys were decanting oxygen from a high-pressure cylinder with a hydraulic hose with a quarter-turn valve on it. The valve was rusty, the hose was rusty, and I'm amazed that the boat hadn't gone up before then. So, in summary, this is probably the worst diving incident I've ever had to investigate, and I accept the fact that it's not the most financially rich sector of industry, but there are basic safeguards that should be in check, and if some level of due diligence had been done on this project, then I think there might be a happier conclusion to it. Case study 2. This is decommissioning. So the majority of the really big offshore structures went into the North Sea in the 70s and 80s. So we're looking at about a lifespan of over 50 years now. If you put steel into one of the most hostile environments in the world, it's going to have problems. And as the oil reservoirs have dried up, the UK government made a decision that it was time to get rid of these structures. So this involves removal of pretty much all aspects. There are certain derogations if you have a concrete base structure instead of a steel structure in this, or if the steel structure is so big. But by and large, the entire structure has to come out. This is Murchison. So as you can see, they're getting on for 45 years old and almost 40,000 tons total weight between the topside and the jacket. 200 people living on here. And in 2014, it was decided to cease production because the oil field wasn't economic anymore. The jacket, and that's the bit under the water, was removed in 2017. But a lot of people think that these things exist in isolation. So the next slide is just a bit of a route map. It's a real mess of spaghetti down in the bottom of the North Sea. Every platform is tied into other platforms. There are pipelines attached to other pipelines. So when it comes to the subsea part of decommissioning, it can be a really, really difficult thing to do because there are so many interweaving bits. So you have to be so careful in your project planning that you know exactly what you're doing. Critical to this story is something called a towhead structure. Now, I'm not sure whether you can see that or get a sense of scale, but hopefully the van will give you. These are massive subsea structures. And when you have to connect lots of bit of the subsea infrastructure together, this will be brought out, and it's kind of like a junction box, really. You can plug in other pipelines or control umbilicals, and it just makes life easier for the commissioning of such offshore structures. Okay, underwater decommissioning on this project involved the removal of that large structure that we just saw. The entire project plan was based around cold cutting, and by that I mean things such as diamond wire cutting and hydraulic tools, so things that don't have an active ignition source. Diamond wire cutting is pretty safe. These two things were devices I used in my own career when I was decommissioning structures in Denmark. And this little tool here is a hydraulic nut splitter. So if you're trying to take a pipeline and all of the nuts are really rusted in there and you're not going to get them off, you can put this on, pump it a few times, and it effectively drives a chisel into the nut and will split it open. So the whole project is planned around using these pretty safe means of decommissioning. However, when the divers got to the site, everything was welded, so they weren't going to be able to use these hydraulic tools. And the decision was taken to move to oxy-arc cutting, or oxythermic cutting, or you're in the industry, broco cutting is its kind of its term. Now the point to take here is that there was no management of change. So the decision was made, okay, guys, these tools aren't working, let's go with the oxythermic cutting. What follows now is 4 videos of the incident. We have Diver 1's helmet camera, Diver 2's helmet camera, the internal camera from the diving bell, and then a vision of the ROV that is looking holistically at the incident. And what the labs at the Health and Safety Executive do is time match them. So the whole incident is going real time on these 4 cameras from different perspectives. This is the towhead structure. And this is the area that the diver was oxythermic cutting. What's important to say here is when you are oxythermic cutting, it burns at over 5,500 degrees Celsius. That splits the water molecule into hydrogen and oxygen. As we know, hydrogen doesn't work well.
You know where you made the second cut before, can you come further in, closer to the pipeline? So you can't make the cut further in first? Yeah. No, that's not possible. Okay, if you need to cut, he's saying it's too hard. Okay, make the first cut the same as last time then. Roger, it's hot. Cold. Hot. One of those things on the other side. Cold. Fucking hell. You right, Pierre? That was the whole thing just went, was it? Good. End the bell, Graham. Come up on the diver. Diver 1. I don't know. Yeah, 1, 2, 3. Yes. Soon as you can, Graham, get the man lift down, keep coming up on him, and flood the bell. ROV, follow the divers back. I'll stop on 2. Okay, get him up there, Scott, as soon as you can. Hello, Pierre, 1, 2, 3. You're heading back, Pierre, we've got you in hand. You're just about there, Pierre, we're just about there. Okay, well done, Scott, get him on that club. Yeah, we've just about got you there, Pierre. You're looking good, mate. Hang in there. Okay, he's conscious. He's conscious soon as you can. Get that man left out. He's conscious. Yeah, it's coming down now. Yeah. Yeah, you're right, Pierre. We've got you, Pierre. You're back on the club, Pierre. Just take it easy, Pierre. We've got you. You're back on the club. Okay, as soon as you can, get him in that trunking. Okay, nice and easy. Coming through the trunking now with him. Well done, Scott. Good work. Okay, Pierre, we've got you. Bringing you in now. Okay, that's good work, Scott. Well done. Brilliant job.
So what were the lessons learned from that incident? Well, what you can see there is a very, very well-drilled dive team. This team has obviously spent a lot of time on emergency drills and getting divers back to the bell. I can assure you, as someone who has done these drills in offshore and at diver training schools, it is probably the most physically intensive thing I've ever done in my life, dragging someone back from there. Well-drilled teams that conduct emergency drills on a regular basis will have a much more successful outcome when it comes to a real-life incident. And we've got stacks of evidence to back that up, absolutely stacks of it. People will often say to us, oh, but the client won't give us time to undertake the emergency drills. Well, first of all, yeah, okay, there are some clients that are pushy like that. But when I was supervising, if I got pushed back from the client then, I would just tag the emergency drill onto the first dive of the project. Okay, the client's not going to give me an hour to do emergency drills. I'll dive the first dive, and when it's time to come up, I'll crash the standby so we can get a real-life drill done, and it doesn't take up any of the client's time. So there were ways around it. I think the second learning point from this was, if you were looking at the camera in the diving bell, you would have seen that the diver recovery hoist was a length of rope with pulleys. And what transpired out of that was this equipment really isn't fit for purpose. In an emergency, the bellman was really struggling to untangle that and get it working. So at IMCO, we currently do have an initiative to look if there is an alternative, better solution to these problems. So what went wrong with this? Well, again, the people. Why did no one stop the job when they moved from a cold cutting solution to an oxythermic cutting solution? Why did no one say, hey guys, this isn't in the risk assessment. We shouldn't do it. So it's a failure of the competence and the training system. And what's really interesting about this project was when time came a year later to remove a similar structure, the client learned their lesson, and the client paid to hire a diver training school for several weeks, and they paid for the company's diving contractors' divers to go to training school. They paid for the supervisors to go to the training school, and they paid for the project engineers. So the client was then satisfied that everyone on this job was competent to burn and supervising burning projects. The paperwork obviously failed, and again, in the offshore industry, I would say in my experience that the one thing that tends to fail is the management of change procedure. This should be a documented procedure based in risk assessment, so if you do deviate from the planned system of work, it's a robust system and everyone knows what they're doing. But what actually came to light in this particular project during my investigation was that it was a lump sum job, not a day rate job. So there was pressure on the diving contractor to get the job done. And I suspect that was the main driver in why this incident happened. And looking at the equipment, well, there was an assumed level of competence. I've been that guy offshore. When the diving supervisor says, hey, can anyone burn? Everyone puts up their hand. It's a great job. People love doing it. Divers love doing it. But it was assumed competence. There were no background checks done to make sure that the divers actually were. And a failure to plan for contingencies, not being able to use the cold cutting equipment. So the lessons learned from this particular incident, and as Mike so eloquently put it in his presentation, this is a fundamental part of any diving safety management system, is when there is an incident, a near miss, or indeed a positive observation, there should be a feedback loop to put those lessons learned in so it doesn't happen again. So the lessons learned here were the people, the training, the competence, the paperwork, the management of change, and the proper selection of equipment for the job. Mike also showed this slide, and I was going to ask the room about it, but Mike's spoken about it. Any diving supervisor, any health and safety professional will know that elimination of the risk is at the top of this hierarchy. This is the one way that you can pretty much avoid every single incident. So how did this resolve itself? This bit of structure still had to come out. What they ended up doing was just getting a bigger boat and lifting it out in one. There was no need to dismantle it at all. They could have eliminated all of these risks and these risks to the divers just by getting a bigger boat in and removing the whole lot in a oneer. This YouTube video is pretty long, so I'm not going to make you sit through it, but that's what's happened. And right, I think I've got about 10 minutes for questions if anyone would like to speak to me.
Yeah, thanks. Zimbabwe Nalomondo, South African Maritime Safety Authority. I think on the first presentation you spoke about most incidents taking place around ship husbandry. And I'm trying to tie a few different systems, and I must acknowledge that I haven't read the document you referred to in that, so maybe it's possibly covered. And and I'm trying to build a picture of how different role players can work together to eliminate some of the incidents you describe, if not all of them, in underwater diving offshore. And in the presentation earlier, we saw the role and the understanding of the HSE, and I think a very much similar context with Department of Labor, and some said that we would have to do. And in that context of the 2023 IMO Code on diving and the Occupational Health and Safety Regulations, we speak about the dive platform and the dive systems. And Phil earlier spoke about the customer and the role of the customer. And I think in the context of the customer that Phil spoke about, it's somebody who ordinarily gets diving service. So just here in South Africa, I could think about the SPM as a person who get regular diving to be done. So you could simply put a rule that they should have a quality management system or an occupational health and safety management system in place. Now, on an ordinary ship, you have the ISM or the safety management system, ISM SMS system. And I am wondering how much of the document that you referred to interacts with this variety of systems, whether it's the IMO code, whether it's the ISM code, whether it's the occupational health and safety management system, to make sure that there's no gap. Because I think it's really quite, any gap is where things go wrong. It's however small it is, that's where the cracks are going to get bigger and bigger and bigger until the whole system looks unsafe. If it kills people, if people get injured, and things like that. So I don't know if you can try and comment on that.
No, that's an excellent point, and you've absolutely hit the nail on the head there. Everybody in this room knows how to dive properly. The document we wrote really isn't for diving contractors. It is for the likes of the vessel masters, the port authority, shipping agents who might be asked to get a dive team in a hurry. That's the key area. If we can get safe diving practices into the hands of those people, I firmly believe that we will massively reduce this fatality rate. What IMCA are doing is we've had a series of seminars around the world. I was in Singapore 3 weeks ago, where there have been 2 ship husbandry fatalities already this year. And what was very pleasing there was probably only 25% diving contractors there. The rest were shipping agents, the rest were harbour masters, port authorities, even vessel masters coming in there. So we realise that if we're going to have to move the dial on this, it's not the diving contractors we need to focus on. The other point that you raised there was vessel inspections. IMCA has a system called ECMID, which is a vessel inspection program. We're just putting a very simple question into there. So when a vessel inspector goes to look at a vessel, one of the questions is, does the vessel you're inspecting have a system for underwater ships husbandry and making sure the diving contractor is competent? We're not going to a deep dive here. What we're looking for is just a basic acknowledgement. We've also decided that a lot of people get overwhelmed by diving terminology, diving equipment, and they can't really get a grasp of it. So we're going to focus on one main area, which is the use of scuba for this, and we're going to try and move the dial on that. As you heard in my presentation, 29 of the 30 fatalities we've had this year have been scuba. So if we can shift the dial on that, we should save some lives.
Thank you, Bill, for an informative presentation. Thank you, Bill, for your presentation. My name is Somika Zichali. My point is, it's not a question, maybe it's kind of an advice from IMCA, is that the department has been emphasizing some of the things you've mentioned on your presentation, but we're struggling with culture change. The incidents that happen, it's reoccurrence, things that have happened in the past, and we feel that the inspectors, we have mentioned what needs to be done, how it should be done, but they keep occurring. Like, we're not sure now what the industry needs to hear, what they need to know, because what you've just presented, it's what we've been preaching, it's what the world has been preaching, it's what all the documents are saying, but we're struggling with culture change.
Again, this is something the UK HSE really struggled with in the past, and it's My advice, what worked for us, is go for the clients. We have a Regulation 4 in the UK, which puts a legal responsibility on the clients or anyone else. So in the offshore industry in the UK, we go for the oil companies. If it's renewables, we go for the wind farm companies. If it's a dock or harbour, we go for the port authorities. Once you start going for the employer of the diving contractors, they will change the rules. They will put systems in place to ensure that they are checking the competency of the people that they... And that was the biggest change that we found in the industry, was instead of focusing on the divers, go for the clients.
Hi, Bill, and morning, colleagues. My question is more around the issue of emergency situations. Our regulation, where it talks about commercial diving, it prescribes at least level 2 first aid. Now, level 2 is better basic in my understanding. I'm saying that because you have advanced, which falls outside the 3 categories that we are responsible for as the department. Now, would it not be better to have specialized kind of first aiders that would be operating in the space of diving, as opposed to taking the generic kind of first aid and plug it in a specialized environment that requires a special kind of understanding of what can go wrong?
Again, a very, very valid point. There's 2 parts to this answer. The first one I'll use for my regulatory head-on, and the second one I'll give you the IMCA answer. UK regulations are goal-setting regulations, and they just say that there must be a number of people with a first aid qualification for the inland inshore diving. Offshore diving changes a little bit, and maybe Ali can put some meat on the bones of this one, but offshore diving, there has always been a recognition that there is no immediate medical assistance to hand, so first aid is not a suitable, well, it's better than nothing, but if you need to intubate someone, if you need to put an IV drip in, if you need to stitch someone up, a first aider is not going to have those skills. So the diving medical technician course was set up 20, 30 years ago? 30 years ago. And when I did it in the 1990s, it's changed a little bit now. You're going to lectures given by doctors or paramedics during the day, but in the evenings, you were actually working in a hospital in the A&E wards. I was stitching people up. I was intubating people. And it was a level of experience that you can only get in a medical background. So what the offshore industry says now, and I can't remember the UK regulations on it, but what IMCA say now is there must be a suitable number of people in the dive team with this diver medic qualification who are capable of undertaking this higher level of medical intervention. It doesn't specify the exact number, but the general rule is there should always be someone to be able to undertake that. So if your only diver medic is diving, then obviously there's no one to treat him. So as a minimum, you'd expect 2 or 3 of them to be able to undertake that. And that's the way it works offshore, and that's how IMCA looks at it. But the short answer is, yes, there is an advanced qualification. If you're working offshore, the risk assessment should prove there are enough people with it to be able to manage a medical emergency.
Thank you. I'm Colonel Lawrence from the police, like you know by now. We are not like in the offshore business, like you have explained now. So my question is more curious regarding your investigation, seeing that we are police and also do investigations. You mentioned that most of the fatalities that you have investigated was about 29 of the 30 were scuba divers. Now, I'm just curious, the reason why these so-called scuba divers died, would you say it is running out of air? Is it the lack of the fact that they are not using communication, that they are not tethered? What is the main reason for those scuba divers being in this fatality high rate? So that is my question.
No, that's a really good one. I'm sure you're an investigator. You're a law enforcement, and I'm almost certain that when you're looking at autopsy reports for dead divers, 9 times out of 10, the coroner will say either death unknown or death by drowning, and that's the same in the ship husbandry. If they can't find a source, if there's no trauma, if they haven't been hit by a propeller or crushed by a boat, then generally, rule of thumb is something's happened with the breathing gas, they've run out of air. So I think that's probably the primary solution. Now, why they've run out of air? It could be entrapment. We've certainly seen people get tangled up in ropes. It could be different kinds of entrapment. We had a recent one where a diver went into a confined space underwater, couldn't get out. So there are various mechanisms, but I would say that drowning is probably the most common out of all of them.
Thank you, Bill, for a great presentation. It's Bridget from the Academy again. Many of you know that I'm in the diving industry because of the incidents that have occurred. I've resuscitated and buried many a diver. I've allowed many a diver to survive, and I spent 49 hours in a very compromised position in a diving chamber trying to save someone's life. And that's incredibly difficult when your resources are very limited because you don't have the hospital around you and all this fancy stuff. But that's enough of that. So I dedicated most of the time in my work in commercial diving into emergency response planning. And just to let everybody know that I actually have written a module, and it's available to all companies. I presented it at an IMCA conference in Singapore in 2017. It was extremely well received. It also included the training of diver medics. And it's emergency response planning. It's the golden thread. And you know, my opinion is at training schools, we can't teach you anything about your job. That's your career out there. But what we can train you is how to dive safely, and excuse the French, if the shit hits the fan, you know exactly what to do. Because when you're under that pressure, you have to have almost an algorithm to follow, and you don't have choices to make, you only have actions to take. And we speak so much, and we put out 68-page documents. There are only a couple of key things that you have to understand in order to get back to safety. And often, like you saw in the movie, we're usually trying to bring person out of a hazard into an unconfined environment. In saturation, we're bringing them out of an open environment into a confined environment that even proves more challenges. So I really, it's a well-received presentation, and I would just like to say, for the name of the emergency response plan, it requires structure and processes. And when that's integrated, it produces systems relevant to your working environment that leads to optimal outcomes and survival during major emergencies. And the plan should be available to all employees, and it's very specific to the person. So the first aid for supervisors, I'm not too sure, because the supervisor shouldn't be having his hands on doing first aid. He is the integral person in making sure that response works. His divers need to understand first aid, how to use a stretcher, how to put on oxygen. I've evaluated many an emergency response procedure, and God forbid, it's amazing how divers can fit oxygen together and what they put on someone's face. So there's all these corrective actions, and they're so simple to do. But you have to understand everyone's clear role in that procedure, and it comes from the client reps, the IOGP, it comes from right at the top and right from the bottom in order to save that someone's life with an optimal outcome. And if you'd like to know anything about the module and the competency assessments I've written to assist in that, it's worked extremely well within our company, and I'm open to any questions and comments. Thanks.
No, I'll just reiterate what Bridget said there. I've seen emergency response plans, which are a folder full of paper. That's not going to work in an emergency. Best ones I've seen are 2 sheets of paper with a load of photographs saying do this. They're laminated, they're stuck where they're needed, and people can follow them in an emergency.
Thanks. Hello? Oh, good. Yeah, just to say something about the IMCA Diver Medic course. I have been asking the department to try and recognize the IMCA Diver Medic for internal South African application. And it's out of their hands because the Department of Health refused to accept the IMCA Diver Medic qualification. So that's our problem, and many companies that work in South Africa have adopted the IMCA Diver Medic, but it's as a voluntary system because the governmental side, the Department of Health, will not accept it under the medical qualifications. It's a very good course. There's nothing like it in the world. It's a brilliant course. And unfortunately, I think the similar thing happened in the UK. I did my first Diver Medic in Plymouth in the UK when it was under HSE. Yeah. And then eventually the HSE had to stop presenting it because there was also implications with the health and the medical health department. So we sit with the same problem in South Africa, and all we can do is train the divers as IMCA Diver Medics, which is required offshore. But the shortfall is we can't force the Department of Health to accept this qualification. But taking it on voluntarily provides major assistance for the divers compared to level 2 first aid. And we all hope that one day we can try and break through, but it's very difficult because it's emergency medicine in remote locations. And now you're sitting in a country where you've got a service, maybe it doesn't arrive in time, but they won't accept the guy does a 2-week course and he can put up an IV line, you know, and these are the problems we face. But the IMCA Diver Medic is an excellent program, and I must say most of the local companies in South Africa that are active in semi-offshore, even in shipping, most of them do seek out guys with a Diver Medic qualification, and it provides excellent training. It's just sad we're not going to get it under the Health Professions Council, and there's nothing we can do about it. It's just how it is. But yeah, we wish we could, but we can't, and it's excellent training. There's nothing like it in the world for divers, and it's sad that there's no avenue to actually take it on, you know. We've got diving doctors that are DMP2, level 2. They're supposed to be advising the diver medics. So do we really need these doctors? I don't know. If we don't have a diver medic course, who's the doctor going to talk to? You know, he's talking after the fact, you know. So that's one of the sad parts of it. But hopefully, in the whole world, we'll get this diver medic course accepted because it saves lives. It definitely does. It makes a massive difference. Yeah. Thanks for your speech. Very interesting and appreciate it. Thank you.
No, you're welcome. There's just a couple of points I'll make there. You're absolutely right. And we do face challenges around the world with the legality of the Diver Medic course. In areas that people don't expect, I don't mean that geographically, but the use of oxygen in 2 major diving countries in the world, the Netherlands and Brazil, oxygen is a controlled drug, and you have to be a trained paramedic or doctor to give it. So there's a wee bit of an issue there. Secondly, you were talking about liaising with a doctor offshore. What we're seeing in the UK sector offshore now is the prevalence of a telemed system or a DMAS system. Because of the likes of Starlink, there are now very good comms between offshore and onshore. And these telemedicine systems, the divers can basically cover the casualty in oxygen sensors, heart rate monitors, I think even ECGs, blood pressure monitors. And all this information is sent real time to a doctor on the beach who can advise how to help. And these are incredible bits of kit. They're not cheap, but certainly we're seeing the major oil companies now stipulating contracts that the diving contractors will have these on board.
I think this is, sorry, I need to cut for time. This is Dr. Mankey's, and then it's really quickly, but yeah, afterwards we'll be around to discuss.
Yes, so Jack Mankey, Stellenbosch University, and a representative from Sahuma. So just to add on what Grant and the others are saying, there is a problem with the regulation in terms of the Health Professions Act, that as soon as you move beyond basic first aid and you want to be involved in invasive procedures, you must be registered with the Health Professions Council when you are involved in performing invasive procedures. And so that's where the problem comes in. So even adopting the diver medic system voluntarily within the borders of South Africa is illegal because you are practicing a skill for which you must be registered as a health professional with the Health Professions Council. So we are actually planning a conference as SHUMA in April next year with the Department of Emergency Medicine, where we are trying to discuss these very issues. We've recently had our DMAC meeting, and the question was asked, do we need to develop a DMAC kit for inshore diving? And some of the companies, some of the doctors, they said, no, it's not a problem. We just phone our local 911 and the paramedic is on site. And I said, well, welcome to Africa. We don't have that available. There are places in South Africa where we dive on the dams and in rivers and places where they won't come for days. And we actually do need an inshore DMAC 15 let's call it the DMAC 15B kit. And so I'm actively, as part of DMAC, developing these sort of guidance kits for inshore. But we constantly run into this legality issue because you have to be registered to do these things. But we are actively talking with the regulator in this regard as diving doctors to say that we do need some sort of a skill, and then the question is how do we then recognize the competency? So there is some movement, but as Grant is saying, at the moment it is illegal. So it's important for people to understand that even voluntary adopting this, if you are trying to put up a drip and something goes wrong, that is a medical legal risk. Doctors pay a lot of insurance money against those sort of things, so companies must just be aware of this.
No, I was going to say, excellent comment. We'll take that on board. And if you need assistance with that meeting next year, Ali is as you well know, is the permanent secretary of DMAC, and through him, IMCA can help.
Yeah, thanks. I think it's almost exactly the same problem we have with training seafarers. What has just been said by Grant and also emphasized by, I forgot the doctor's name there, but I also want to get on the bus of the discussions you're having with HPCSA and an invite to that conference. Thanks.
Okay, thank you, Bill. No, we're done for questions, sorry. We've got a time to keep as well. Thanks for that hour. It didn't feel like an hour, but I think everyone learned from those case studies that were presented, especially when during that video was playing, I'm sure we could hear a pin drop in this room. So moving on, so our next presentation is going to be from Mr. Fani Kruger. That's going to be on the application of occupational hygiene principles in the commercial diving sector. So just a bit of background on Mr. Kruger. He is the founder and part owner of one of the Department of Employment and Labour's approved inspection authorities, that is SafeNet Africa. He's also a registered occupational hygienist with the Southern African Institute of Occupational Hygiene, and his registration number is very low, so that means he's been around for quite a long time. In his former life, he was also an inspector at the Department of Employment and Labour, but back then it was a different name, where he also did his diving training as a Class 2 commercial diver. I won't say the year, Fani, but it was a while ago. And he also helped with writing one of our first regulations on diving back in 2001. So, he's on both sides of the fence now at this this conference. So yeah, if we can just give Fani a welcome round of applause. Thank you.
Hi, everyone. Thanks, Warren, for that introduction. Let's just see here. Is the presentation ready? Oh, there it is. Like Warren said, I'm Fani Kruger from a company called SafeNet Africa. And we specialize in occupational health and hygiene. And we are also approved by the Department of Labour to perform these functions within the industry. Department of Employment and Labour have asked me to do a presentation on the application of the occupational hygiene principles in the commercial diving sector. And because of my background, as Warren mentioned, and being an occupational hygienist, I would like to introduce you to this type of work that we do, but not also, for us as hygienists, but also that you can apply those same principles when you do your risk assessments of your particular work activities. So everything starts with the Occupational Health and Safety Act, and I think you're all familiar with this piece of legislation by now. In particular, if you look at Section 8.1 of the Occupational Health and Safety Act, where it clearly states that the employer must provide and maintain a working environment that is safe and without risk to the health of his employees. And I think there are two very distinct concepts here. The one is occupational safety, and the other one is then what is occupational health. And occupational safety addresses potential safety hazards that can cause injury, whereas occupational health addresses potential health concerns. Now, my presentation today would focus mainly on the occupational health side, because as an occupational hygienist, we look at health and hygiene, and not so much focusing on the safety aspects. In other words, safe use of plant and machinery, or where people can be physically injured or harmed when they use a piece of equipment. So, what is occupational health? There are three pillars to occupational health, which includes your occupational hygiene. And sometimes I get a question where people ask me, what do I do for a living as a career? And I say I'm an occupational hygienist, and they don't have any clue what that entails. All right. But I'm going to introduce you to that world just now to see what we do and how you can benefit from that as well. Then you find the other two pillars of occupational health is more related to the occupational medicine side of it, where the doctors and the sisters, occupational health people become involved, which is your occupational medicine and the biological monitoring. So typically, just to give you an example, let's say within the industry, somebody is using a particular chemical at work. Let's say it's acetone. They need to know what the levels are of exposure. So what we can do from an occupational hygiene point of view, and as a hygienist, we can actually go and measure those levels. All right. But legislation, and typically I'm referring to the regulations for hazardous chemical agents of 2021, we typically say, but that particular chemical, acetone, is also a chemical that if people are exposed to that, there's a need for those people to be subjected to medical surveillance. In other words, the medical surveillance then meaning that the doctors would look at our reports, and yes, they see that the person is exposed to acetone, but as far as the biological monitoring is concerned, so is it necessary to take a urine sample or blood sample to check the levels inside the body? That would be entirely up to the doctors to decide. So we wouldn't become so much involved in those two pillars. Our main focus is then on occupational hygiene. In terms of the principles of occupational hygiene, If you look at the definition, the International Occupational Hygiene Association, I'm going to use their particular definition of occupational hygiene. It says that it refers to occupational hygiene as disciplines for anticipating, recognizing, evaluating, and controlling health hazards. And as I mentioned, the focus here is on the health hazards in terms of my presentation. And in the working environment, with the objective of protecting worker health and well-being and safeguarding the community at large. All right, so if we look at the occupational health hazards, I've put together this slide that tells you, all the different categories of occupational health hazards that you can encounter or may encounter in the workplace. And they're categorized into 5 major groups: your physical, your chemical, biological, ergonomic, and psychological stresses that you can or may encounter. So if you typically look at your physical stresses, that's what we refer to them to. Excessive noise that people might be exposed to, and which can result in noise-induced hearing loss. There's ionizing and non-ionizing radiation. Difference here, you would find a radioactive source, like people working in a hospital and performing X-rays, for example, non-destructive testing, where they use a radioactive source. That's ionizing radiation, or non-ionizing. In terms of, inside a factory, somebody's welding in a welding bay, in a workshop, and there's lots of radiation coming from that process. That typically would be classified as non-ionizing. In other words, it's not going to penetrate the body, it's just going to start heating up the surface of the skin, and especially for welding, people may get skin burn or suffer from arc eyes. All right. And then what we also look at is hand, arm, and whole body vibration. The Department of Employment and Labour has issued a draft physical agents regulations that was out for comment, and that is also mentioned in that particular set of regulations. And we find all the more that we request from clients that we do hand, arm, and whole body vibration testing on employees. Okay, then also your extreme temperatures, and this is also something that divers can be exposed to. If they dive in very cold water, there's always the risk of hypothermia. And also operating in areas where there's lots of heat present, radiant heat, and your wet bulb temperatures are extremely high, which can result in dehydration, heat stress, or heat stroke that people can suffer from. And then illumination, it's also, there should be sufficient light in the workplace. And we always try and see if there's a nice even spread of light. So we have special instruments that we can measure the lux levels as well. And then extreme high-low air pressure. I'm specifically looking at the diving fraternity now. If somebody's in the chamber, that they're exposed to high pressures. There's always a risk of some barotrauma, perhaps, or eardrum bursting, or also the risk of decompression sickness. And then different water pressures as well. So in other words, one is inside a chamber, but you can also dive in the water, and obviously your pressure differences that exist. If you look at chemical exposures, you'll find gases, vapors, mist, dust, fumes, liquid, and fibers, things that people might be exposed to. And again, as I mentioned a bit earlier, we're looking at the regulations for hazardous chemical agents in South Africa that would prescribe certain occupational exposure limits that you're allowed to be exposed to. I'm just going to talk about this a bit later in terms of diving, because obviously air purity, quality of air that you provide to a diver is of utmost importance. And then there's the biological hazards that people might be exposed to, bacteria, viruses, mold, fungi, human endoparasites, and also, especially for divers, marine life can also be a concern. And then ergonomics, this is also something that is receiving special attention at the moment in South Africa. We have the ergonomics regulations of 2019, and which requires of employers to conduct ergonomic risk assessments of work activities. So there are sort of three focus areas for ergonomics. We're looking at your physical ergonomics, which is your work-related upper limb disorders, your manual material handling, push-pull activities, and also for people working in office environments. There's certain calculators that we can use, which gives us a very objective risk assessment in terms of exposure to those ergonomic hazards. And then also we can look at cognitive ergonomics, meaning ergonomics of the brain, and also we look at organizational ergonomics. And this actually fits in very well with the theme of the Department of Employment and Labour, where we're talking about having health and safety management systems in place going forward. You know, the better the organized the work area, that would also have positive impacts on organizational ergonomics. Then psychological stresses. Look, it's not to say that we will always become involved as experts in that particular field. The industrial psychologists can also become involved in this type of field. But yes, there are some examples that can lead to also psychological stresses on people, like for instance, excessive workload and overtime, shift work, stress, that they experience, challenging working environments, operating complex machinery and equipment. All right, so those are the 5 different categories. So it's going to give you some idea of what the health hazards are that people might be exposed to. All right, so the first, if you again look at the definition of occupational hygiene, the first principle there is anticipating. If you start with a risk assessment of a particular work activity, and let's say you have to go and dive at a particular location, but because of your past experience, your qualifications, your background, your training that you've received, you can already anticipate that there might be certain hazards already present at that particular work site that you have to deal with. So for instance here, anticipation involves identifying potential hazards in the workplace before they are introduced. For example, if diving in a sewer reactor must take place, we can anticipate that there will be numerous biological hazards present. Zero visibility is going to be an issue, and also you're not going to have any buoyancy. All right. Recognition is the second principle of that definition of occupational hygiene. Is the process of identifying potential hazards in a workplace. For example, when arriving at a dive site, you recognize, or the other word for that is identify, various hazards that was not anticipated. For example, contaminated water, strong underwater currents, extreme cold water temperatures, excessive noise from surrounding activities, low water visibility. All right, and again, it forms part of your risk assessment. So yes, beforehand, we can anticipate. However, if we get to the site, it might be a different picture altogether. And you have to identify those new hazards that you not necessarily would have anticipated. All right, so the next one is evaluation. And that is the process of identifying and assessing workplace hazards to determine if they are within acceptable levels. For example, taking a water sample and have it analyzed for the presence of E. coli, taking measurements of water temperature. So let's say you go right to the beginning and you anticipate that you're going to a dive site now, that perhaps you're not going to be exposed to contaminated water. However, if you arrive on that site and you identify, yes, the water doesn't look very good, the quality of that water, but you are unsure if it's safe or not, you can always take a sample. So that's where the evaluation part comes in, and get the results so that you know, yes, this is what I'm dealing with. All right. And this is where we come into the picture as occupational hygienists, because this is what we do for a living. And we have quite a few instruments that we use. For instance, if people are exposed to noise and we have to find out are they above or below the noise rating limit of 85 decibels, we've got a sound level meter that we can use to determine that. So we evaluate that particular hazard and find out if it's within the limits or not. And then the last one, as part of the principles of occupational hygiene, and I see some of the other presenters have already made use of this upside-down pyramid, comes from NIOSH in America. And I just want to go through it again. So there's a set sequence that we always apply when it comes to control measures. And this is basically what we use. So if you have a particular hazard, first prize is always to either remove that hazard completely, and if the hazard is no longer there, there's no risk of harm to that particular person. The second one is the substitution, and that is basically to replace that hazard with something that's less harmful. A very good example in the industry is where people might use a harmful chemical, and you can always replace that chemical with something less harmful. All right. And then the engineering controls is to isolate people from the hazard. So if you have a particular noisy area and you've determined that there's one particular machine that creates that noise, it's always an option to enclose that particular machine, isolate it so that it doesn't cause a noise problem to the whole particular area, and everybody is exposed to that. And then administrative controls, change the way that people work. Yes, previous speakers also mentioned that you can have safe standard operating procedures, and you can provide training, information, instruction to people to do the work safely. But there are many ways that we can also administratively look at to change the way that people work. And then the last one, and even in our legislation, the OSH Act, we talk about PPE as always the last resort. So we would like to try all those other risk control factors before we just provide PPE to people and think we've done enough. All right. So if you look here, there's the most effective, then to the least effective approach. Okay. So what I'm going to do, because there's quite a few health hazards, and I'm just going to use a few examples. And the first one is noise exposure, and I'm sort of going to link it to the diving fraternity. So let's see. So noise and commercial diving. When noise is propagating in air, the noise level in decibels is referenced to or at 20 micropascals. So in other words, the average human threshold of hearing at 1 kilohertz or 1,000 hertz is then, that is when you as a human can actually start to hear sound. Okay, 20 micropascals at 1,000 hertz. And that is referred to as the threshold of hearing. So measurements expressed in this way describe the decibel level to sound above the human hearing threshold. So in other words, anything above 20 micropascals, obviously that's what we're interested in. And as occupational hygienists, we use sound level meters that we can measure those levels. Okay. And to account for the sensitivity of the human ear in air at different frequencies, an A-weighted scale denoted by dBA is used and indicates the way in which airborne noise is related to the human perception of sound. Now, underwater, noise underwater is very different than in air and is referenced to a pressure of 1 micropascal at 1 meter. So in other words, 1 meter away from that particular tool, or whatever you're using, so the ear is much more sensitive in water than above water. And typically what we're referring to here also is a wet ear versus a dry ear. So this in particular, the 20 micropascals, that is what you would find in dry air. So in other words, on land, but underwater, which we then refer to as the wet ear, basically much more sensitive. Okay. Now the big difference on normal atmosphere, if you're exposed to excessive noise, the sound waves obviously move through your auditory canal. It vibrates your eardrum, which is connected to the malleus and the inkeys and the stapes, the little bones in the body, which is connected to the inner ear. And it disturbs the fluid in the cochlea, where there's little cilia or hairs, and it's also pressure is exerted on that and through the auditory nerve to the brain, and that's how we experience sound. Okay. But if my ear canal is filled with water, it means that my eardrum is not going to move. So what happens then is that there's a process called bone conduction, so where the sound actually moves through the skull. So water being a different medium, just realize that us as humans, we also have a lot of water inside our bodies. So the transition from, let's say, open water, seawater to the body, through the skull to the inner ear is actually quite a smooth transition. Okay. So there's quite a nice reference document that you guys can also look at. This is where I got most of this information. It's the HSE document RR735. And it's basically a document where they've done a lot of research. They specifically looked at the commercial diving field in terms of noise exposure. But the very important thing to note is it a dry ear that is exposed to sound, or is it a wet ear? All right, so keep that in mind. And the reason why I've referred to this as well, you'll see now why the 20 and the 1 micropascal is so important. So in this particular document, this HSE document, I've got some examples of values that was measured. Now, if you can look on top here, you can see a noise source level is in the water, and that means that the reference value is then 1 micropascals. And you can see here, for example, a person using a chainsaw in the water. This is now for a wet ear. This is what you're going to be exposed to. The 20 micropascals, they say in a helmet. If you look at the noise levels there, concerning a dry ear. So just going back to this particular slide, there's the helmet. So that means you're going to sit with a dry ear in the helmet, whereas opposed to a band mask, you sit with a neoprene hoodie that comes over your head, and the water might then enter into the ear canal, and you're going to sit with a wet ear. So there they give you the differences if it's a band mask, inside the band mask. So it's very interesting, the research that they've done. So there's 162 inside the helmet. If it's a dry ear, he's exposed to 101.5 decibels. And if it's a wet ear, obviously the neoprene material is going to give some noise reduction there to the diver, but it's 66.4 decibels. Okay. So how do we measure? It's easy to measure on the surface in air. We use a sound level meter, but underwater it's going to be a bit different because we need to have a hydrometer. So they give us some kind of solution where they say that airborne and underwater sound levels can be converted by adding or subtracting 26 decibels. All right. So what I can suggest is that, let's say a person has to use a jackhammer underwater, perhaps take a reading on the surface while he's performing that particular task and get a value, a decibel reading, and then if the person is using a helmet, work on those particular readings that you got. It's going to give you some idea. However, if the ear is going to be wet, water is inside, then they say, well, you can subtract 26 decibel. All right. So just to look at underwater auditory thresholds and frequency sensitivity. So the human the human auditory system is most sensitive to waterborne sound at frequencies between 400 and 1,000 hertz, with a peak at approximately 800 hertz. Hence, the frequencies have the greatest potential for damage, and that is particularly in a wet year. So for airborne sound, hearing is most sensitive between 2,000 and 6,000 hertz, with a maximum sensitivity at approximately 4,000 hertz. However, underwater hearing is less sensitive at these frequencies, and so the noise hazard is reduced. Okay, can I just see by a show of hands who's ever been inside a booth where your hearing was tested? I think most of you sitting, and they put you in this little hockey and they give you a button to press with your thumb. So they would say, "You're right, we put these headphones on, so we'll start with your left ear." And they will give you a signal and you need to respond. Okay. Problem is, if you never press the button once and they knock on the window and say, "Come out," you must know there's a big problem. Okay, so let's say for argument's sake, you're inside a factory, you're exposed to excessive noise, you work in a noise zone, you go inside this booth, they test your hearing. One way of identifying that the person is suffering from a permanent hearing loss is that there would be a dip at 4,000 hertz. Okay. So that's the first sign that there might be something wrong with the person's hearing. And that coincides with with this particular paragraph here. So the maximum sensitivity for hearing is at that particular frequency. However, if it's in water with a wet ear, it looks a bit different. So there's the air, and if you look, there's 1,000. So if you move on, so that would be the 4,000. But a wet ear, the most sensitive part of frequency is then 800 hertz. All right. So just to give you sort of a bit more detail, I know it's very technical, but yeah. So hopefully your audiograms would look like this. That's a normal hearing, but hearing loss, a big dip at 4,000 hertz. Okay. Good, so just to apply these principles, so we have excessive noise. We know what the health effect would be. It's noise-induced hearing loss. And now we go through those hierarchy of controls. So in other words, what do we put in place to make sure that no harm is going to come to the person's hearing? So in other words, that you have a decent noise and hearing conservation program in place. All right, so elimination, not be possible. If he has to work with a jackhammer and it's going to generate noise, then obviously what else can you do? You can't say don't work or use the machine. Okay, substitution. Make use of equipment and machinery that generate less noise. There's an example, use hydraulic instead of pneumatic tools. It's going to make a huge difference. Then, in terms of engineering controls, reducing of diving site noise, for example, fitting exhaust mufflers on internal combustion engines, silencers to compressed air, exhaust, etc. And then also helmet soundproofing can be used by incorporating acoustic insulation in and around the diving helmet shell. And then administrative details or controls. You can obtain technical data from the particular equipment that you use from manufacturers, where they can perhaps stipulate what the decibel readings are that this particular piece of equipment can generate, so that you know. This applies to equipment in all aspects of diving operations, including surface machinery, for example, compressors, diving apparatus and diving helmets, diver tools and hyperbaric facilities, for example, your compression chambers. And also very important that divers be placed under medical surveillance, which means that they'll have to go for their audiometric examinations. And the site must keep records of that for many years. And noise and hearing conservation training, develop safe operating procedures for work activities, reduce exposure time if possible. We can always look at the noise dose, meaning over an 8-hour period, what the diver is exposed to. So let's say he's for 25 minutes in the water using a jackhammer. He then comes out the water. He then operates a compressor. at a certain decibel level. So we can look at the whole exposure, 8-hour exposure, and see at what times he's exposed to what decibel levels. And conduct noise surveys. Sometimes it's going to be a bit difficult to do that underwater, but yeah. And then if you look at PPE, in this particular document that I've referenced, there's also specialized hearing protectors for divers that they can wear, but that would obviously be for the helmet to help with noise exposure. And because just realize that the diver still, if there's communication, still needs to be able to hear, still needs to be able to equalize, etc. Then chemical hazards, and I just want to touch on contaminated breathing air being supplied to a diver. I just realized that, yes, the person is in the water, and we need to look after that diver. And one way of doing that is to make sure that clean air, breathing air is provided to that diver. I don't know who's quite familiar with this. Oh, okay. All right. I need to speed up. Okay, so there is the SANS 10019 of 2023 that would tell you about the impurities in the air quality that you need to provide. And so they would list like what your water vapor, your oil particles, carbon dioxide, carbon monoxide, and odors that, in breathing air. So those are the limits that you're not allowed to exceed. And I trust that some of you are familiar with these particular standards. There's a Draeger air purity test kit. Who's got one of these kits, perhaps? I see a few hands. Yeah, so just make sure that you do have proper SOPs, proper training. Make sure that the tubes that you use are still in date, it hasn't expired, because on some audits that I've done, I've picked that up, where the tubes have expired. Okay, all right. So just again, in terms of the principles of occupational hygiene, so there's the hazard, contaminated air that you can provide, and then also the effects that can have on a diver, and then just very important again, the hierarchy of controls. So there is the administrative controls, the SOP that I talked about for conducting air purity testing. The law says every 6 months that you have to do that, according to SANS 10019. All right. And then biological hazards, and I've used an example here of a person diving in a sewer reactor. So what's very important is that there's multiple health hazards associated with that. And as part of control measures, look at the administrative part there. Very important that people need to be placed under medical surveillance. Okay, and that might include vaccinations against hepatitis A and B. If you look at the police divers, have you considered the environments that you guys work in and the things that you guys are exposed to? So consider the biological hazards there that can cause serious problems to your health. And then also the PPE, dry suit, cut-resistant gloves, positive pressure, face mask. But and also, sorry, I just want to mention here that decontamination is very important. So there needs to be proper SOPs for that. Not only for the diver, but also for the personnel on the surface and how you're going to decontaminate your equipment, etc. Okay. And then ergonomics. I'm not an ergonomist, so we will only conduct baseline ergonomic risk assessments, but know that it is a requirement in terms of the law. And I've just used a very simple example for diver entry and exit from the water. So this is not actually what we want, a diver jumping off a quayside. And there can be quite some ergonomic stresses placed on the person's body. So there are some options here. So if you just look at the principles again, yes, there's ergonomic issues. And here, the entry and exit from the water. The health effects, the strain on the spinal cord, and then also if people have to lift things underwater, manual material handling, you might lead to musculoskeletal disorders. And And then, conduct your risk assessments, very important. And also the medical surveillance that people need to be exposed to in terms of ergonomics. Okay, and I just want to conclude by, in terms of psychological stresses, and it's been mentioned quite a few times, is that we need to prevent these health-related issues or diseases and so on in commercial diving. And I think it starts with the diving schools. Just realize that commercial diving is a high-risk occupation. And the diving schools must make sure that prospective divers are deemed competent when leaving the training facility. But I think they need to be bold enough to also inform a diver to say, look, sorry, you're just not cut for this type of work. Yeah, okay. And I think they are cutting me off now. All right, but thank you very much.
Okay, so thank you, Mr. Kruger, again. So yeah, just hope employers out there, you're taking into consideration those other regulations Fani was talking about and not only looking at the commercial diving regulations. So moving on with our program, our last presentation before lunchtime is from Mr. Luke Goodenough. Luke is a Principal Technical Officer and a PhD candidate in the Human Kinetics and Ergonomics Department at Rhodes University. For those of you international, that's in Makanda, or formerly Grahamstown, now known as Makanda in the Eastern Cape. His academic journey in underwater research began in 2016 as a master's student, which has continued into his doctoral studies, along with taking on a supervisory role with postgrad students. He is also a council member of the Ergonomics Society of South Africa, where he contributes to the promotion of the field of ergonomics. And Rhodes University also has a ergonomic short course, which he is also a facilitator and assessor there. So I think his presentation is going to link on quite nicely to the end of Mr. Kruger's presentation on the ergonomics human factor side of diving in the murky waters. Yeah, so we can all welcome Luke, please.
Hey, good afternoon, everyone. Thanks for having me here. My presentation is going to be focused on my department's underwater research and the journey from our first study to where we are now. It's been roughly 8 years worth of research, but I'll warn you, it's a very academic background to it, not much actual out in the water diving. We'll get to it. So to start off with who we are and who I am, this is the front door to our lovely department, and this is our main area for our research. It's basically my research office. It's a hydrostatic weighing tank. It's roughly 5,500 liters of water where we can control clarity, temperature, and light. We have a light rig built above it that's advanced over the years, and most importantly for our research, we have a large observation window to allow us to monitor our participants and make sure that they're safe while conducting our research. So from an academic perspective, the literature surrounding underwater work is fairly limited. Most of the research is military-based research pre-1980s, focused on assisted breathing, either scuba or surface-supplied air. Not a lot of research done on apnea diving. Most of that research is linked to the human dive response or the mammalian reflex. Like I said, a lot of military research, and the more recent stuff is mainly NASA-based, using an underwater environment as a proxy for space. NASA have a giant pool they put their satellites and astronauts into to conduct their research. You will all be aware of the dangers and risks with underwater work. It becomes dangerous. It is a very high-risk environment, high-risk field. The implications that has for work is diving is, in the literature, a mainly observational occupation. You've got restricted movement, altered inputs of information. You're restricted mainly to visual inputs, and your environment is dangerous due to various reasons, which makes the work difficult. Our background is, like I said, academic research projects. We started in 2016 with my master's, and to date we've got one ongoing PhD myself, 1 ongoing master's student, 1 completed master's, and 6 completed honours projects. To put perspective into that, a master's degree is normally around 2 years, and an honours project within 1 year. We also have 1 paper published so far in the Ergonomics Journal of South Africa. That should be coming out relatively soon. So our knowledge base into the world of academia for underwater research is growing. So what have we focused on mainly throughout our journey? And that is looking at different types of breathing. So we've tested normal breathing, obviously like we do on land, assisted breathing, as well as apnea diving, which I know isn't necessarily regulated, but does form a large part of underwater activity in South Africa. We've looked at visual acuity, basically your eye test, how well you're able to see underwater. Working postures and the impacts of gravity, because when you're underwater, you could be neutrally buoyant. Okay, that is just turned off, so I will be turning around a lot. We have then looked at the changes in the physical environment from highly controlled to less controlled, the impact of varying light levels and varying levels of turbidity in the water, and most recently looking at the impact of experience with underwater work on people's ability to perform. We started out using standardized ergonomics tests that we've used in research in the department. All of these, bar this one, are computer-based tests, hence the use of the hydrostatic tank. It allowed us to put a computer monitor against the screen for people to be able to conduct an office-type setup and perform activities, but with a different physical environment around them. Thank you. We then moved on to a visual acuity test. This is a Landolt-C visual acuity test. You will have all seen the Snellen letters one at the optometrist. As you go down, they get smaller and smaller. In this one, the participant's instruction is to give the direction of the opening in the sea. We then moved on to a fine motor control task. If you've got kids, you'll have seen one of these. It is just a shape sorter puzzle. It's got 6 sides, 2 pieces go on each side. We had that for people to have to figure out where they are and perform the test. We've also used it in a flat configuration just to allow for ease of change of tasks. And most recently, we've gone to a manual assembly task, something that's a little bit more industry specific, which is nuts and bolts and a pipe assembly. So the first study where we started, we were looking at different breathing types on performance. So on land breathing was our control, and then we had participants underwater with assisted breathing and with apnea with breath hold. So this was the testing setup. As you can see, keyboard and mouse on land. This is from behind the monitor. So participants were completing, it was almost like an office type setup, but underwater. And this is what we found. So the red is, so if we look for statistical significance, shows you where differences were found, and then I don't know if you can see the asterisks indicate which condition had the better performance. So for most of them where there was a difference, performance on land was the highest, which is to be expected. One area of interest was here for the recognition task, so they were doing a proofreading task. When assisted breathing was used, so in this case it was scuba, participants read, so went through more words in less time, but identified less errors. So there was an increased reading speed, but an increased error rate at the same time, which was quite an interesting finding. We also tried to use experience underwater as a continuous predictor, but it didn't really show us anything, and that's probably a limitation to the type of tests used. We went then on to a visual acuity test with our Landolt-Cs, again, breathing as normally as possible underwater using some snorkeling apparatus. And we varied the light levels. And again, land performance was superior with 350 lux, which is quite low, being the poorest performance, but there being no significant difference in the performance between 550 and 1,000 lux. So whether increasing brightness helps or not is unclear, and there was no interactional effect between the environment and light, so going into the water with varying light levels didn't make any significant reductions in performance. We went from there onto a postural study, so as one of our honours students trying to display their project without using too many photos, and this was having people perform a fine motor control task, the shape sorter puzzle, in 3 different postures, comparing performance underwater to performance on land. And there we found again, performance on land is superior, which is becoming, we're seeing as a trend. Underwater work is harder. Forgive the typo. Upright work was the best in both conditions, with supine and prone work not being statistically different, but supine work being the slowest of the 3. So lying on your back was the slowest, on your front, next best, upright was the best. Then we looked at the effect of neutral buoyancy and the direction of gravity. So we started with people working upright, both neutrally buoyant and under the effects of gravity, supine and prone, and an on-land seated baseline assessment. And here we found that buoyancy and posture do not interact, so whether you are neutrally buoyant or under the effects of gravity did not affect task performance. Upright was again the best, supine was the slowest, and then supine while neutrally buoyant without that gravitational effect to give you any sort of indication of what you were doing was, the performance was worse yet again. The physical environment, we again used our tank as a controlled environment, perfectly clear water, 30 degrees Celsius, very comfortable to be in. We test with students in Makanda. In June, it's freezing. No one's going to get into water that's not warm. But we did manage to get some of them into the Rhodes University swimming pool, which was at around 15 degrees at that time. They did a reading task, both high and low resolution text. Unsurprisingly, the higher resolution text had better performance, which, yeah, that's a bit obvious. And then there was an interactional effect found for error identification in that the low resolution text performance was worse in the controlled environment. There was no difference found, however, between the less controlled and more controlled environments, which from a research perspective means we may be able to find inferences for different tasks without having to expose participants to the additional risks of cold water stresses or open water environments. For one of our most recent studies, we looked at the impact of light on a manual assembly task. The move into this direction was to try and get more environmental validity and task validity with the kind of work that is actually performed underwater. There were no differences found for varying levels of light. The brightest light, however, was found to be the slowest, but not statistically so. We then moved on to looking at an experience study using recognition and a manual assembly task. This one had some quite interesting findings in that the condition mattered in the recognition task, with on-land performance being significantly better, but it made no difference for the manual assembly task. People's ability to perform the task was the same on land and underwater. However, underwater experience, regardless of condition, improved manual assembly performance. It's a bit of a weird finding for us. We haven't quite figured out an explanation, but it does seem to indicate that participants who had previous underwater experience, most of it would have been recreational scuba, performed a manual assembly task better than people without that experience, regardless of condition. So as I've just been saying. And then our most recent master study that's still writing up was looking at light and turbidity. In this regard, he had 3 light levels from 500, 600 lux, all the way down to about 130 lux. And the tank, I don't know if you can tell in this photo, we reduced the visibility by 1/3 and then by 2/3 using hot chocolate powder to try and simulate dirty water. And for the fine motor control task, as turbidity increased, so as the water got murkier, performance decreased. But as the light levels decreased, performance improved. So on the brightest light condition, performance on the fine motor control task was the worst. And then for the visual acuity test, again using the Landolt-Cs, as turbidity increased, performance decreased, and as light decreased, the number of errors increased. However, the speed of completion remained the same. With all of that, what does it all mean for us as researchers? Is that simpler tasks seem to be unaffected by condition, more complex tasks have varying impacts. And the biggest finding we found was that heart rate variability, which is used as a measure of cognitive load, measuring the time between beats of the heart, does not work underwater. The human dive response affects heart rate variability, as does the use of compressed air to breathe. So cognitive load is harder to determine, and we have to use subjective measures or use performance times, and performance outcomes is our only means of measuring. From a work perspective, not really relevant to everyone in the room, but for apnea divers, it's quite a red flag because we found a delayed response in memory, not an accuracy response issue. So the correct answers, the correct things were remembered, but at a delayed rate, which when it comes to a critical incident or situation is quite a risk. For assisted breathing, we found that recognition tasks had reduced performance, which if you are doing an visual inspection, things like that, could have an impact on productivity or the accuracy of an outcome. And we also found that excessive light may have a reduction in performance, so too bright of an environment makes work underwater harder. And bright light with moderate to lower turbidities, we have found has the worst outcome for the tests we've used. And then going forward, we would like to do more job-specific research. If that's in situ, that would be best, but the concerns there are you increasing the risk and possibly impacting on the performance of your divers, which from a safety and business perspective, nobody wants. We would like to then go into using diver-supplied light. As I've seen from a lot of the presentations, head-mounted light gear is very, very highly used. Weighted work, the suits and everything you guys are operating in are not light, so what impact that has on performance. You are performing fine motor control tasks while having to do gross motor control in terms of resisting currents, positioning your body, getting to the sites. And real-world conditions. So, I mean, most of our research has been done in a highly controlled environment, mainly for from a safety perspective, but it would be interesting to change those things and, again, more real-world tasks. As I've been watching presentations, we get to see a greater picture of the kind of work that's done underwater. Like I said, from an academic perspective, in literature, stuff is not as clear-cut as it's been put out here, so this has been quite an amazing addition for us. And then I'd just like to thank, the Department of Employment and Labour for inviting me here, and then these wonderful people who conducted underwater research as part of our group. And yeah, if you guys have got questions, that's me in my office. Thank you.
Yeah. Okay, thank you, Luke, once again. Yeah, some interesting results. I'm sure hopefully some of the employers here might speak to him while he's here the rest of the afternoon. You did see the hints on his recommendations there, so yeah. So just we're going to do a quick question and answers for Fani and Luke, if there's any questions. I got one over here, two over here, another one there. Okay, so we'll take those three. At the front here. And then Bridget over there. Okay.
Okay, good afternoon. My name is Bianca van Blerk from the Police Divers, Cape Town. This question will be for Fani, but I do believe me and Fani will sit afterwards and chat as well. He spoke about the biologicals. That's one of our biggest problems in the Western Cape. So my question to him is, he said they can test the E. coli. So we've got a lot of sites that we know we will have scenes, especially this festive. I know there will be scenes in Feleni. I know there will be scenes in Kalicha. And there's a lot of areas that the water is very dirty. We don't just report to labor law, but we do report to SAPS as well. So each area's got their own commander, and each area's got their own captains and everything. So once we get on a scene, one of the biggest things is the community and SAPS expect the divers to go into the water. You can't just rush and put a diver into the water. You need to go and assess everything. You need to do your risk assessment. So my question is to make it a little bit easier, especially for the supervisors. Is there a way, if I identify, say, 10 areas, that we can go test those areas for E. coli? So when I get a scene, I already have a HERA and a risk form. So I can tell that commander of that station, according to labor law, occupational health and safety, this is the reasons why I cannot put a diver in the water because we do not have this, and this PPE. So we need to make another plan. So to eliminate, to get the diver into the water, is there a possibility that we can ask for assistance to go test those areas for E. coli? Okay. Thank you.
Thank you for the question. Can we get a microphone to Fani, please? It's coming.
Thanks, Bianca, for that question.
Look, it's almost possible to measure. Taking water samples and sending it off to a laboratory and get a result is possible. But that might take a few days, you know. So I don't know how that's going to influence your reaction time in terms of what you need to do. However, I think the best thing is to anticipate rather that that will be present. I mean, the water will be contaminated. And I think the best thing would be is to have the correct type of equipment, the diving equipment, like a dry suit, you know, and also positive pressure type face masks and so on. Yeah, as I said, it's possible to measure to get a result for you, but I don't know if it's always going to be logistically, you know, possible for you to deal with. Yeah.
Okay, thank you.
Yeah, Fani, hello, Fani, don't sit. Oh, okay, it's Fani. Okay, there we go. So I just want to link into what Bianca was saying. In the industry, is there no field service kit that can be used just to do a water test that will give you just an indication that there is an immediate high risk for a particular waterway that you're going to work in? Is there nothing like that in development or being looked at? I do know the river that she refers to in one of our waterways is behind Sanitized City, and the bucket system is utilized, and the river is a gateway for that, and it's also one of our prime spots for a particular type of justice that's been done there. So the challenges are always quite high there, but we know from the water that was tested there in the past that the E. coli level is, I think, over 1,000 or something like that. It was quite high, yeah. But that was a while back. But we do need assistance, especially in inland water currently with the rivers, that we have an idea of what areas is regarded as high risk and what areas is regarded as a lower risk, and then align our equipment and SOPs accordingly. So I think a field kit would go a long way if somebody here with some money in something like that. Perhaps our friends there from Scotland, and then sponsor us a few just to test it. And but it's really an issue. So we might look at it lightly, but it does impact on service delivery, and it is a real life and a challenge that we do have. Thank you for your time, and but the kit.
Yes, unfortunately, I'm not aware of a kit for immediate testing of E. coli. If there's somebody else that's got a bit more knowledge on that, they're more than welcome to intervene. However, we take samples, and they need quite a bit of water at the lab. Obviously, they've got to cultivate that particular test for that E. coli, and it takes a few days to get the results. But it's a ISO 17025 accredited laboratory, so we can trust those results and the accuracy. So again, anticipation in terms of the occupational hygiene principles is a thing that you need to rely on because of your knowledge and experience with regard to the areas that you work, and then look and consider your control measures, you know, which in my opinion, a lot of focus is going to be on your personal protective equipment to safeguard you guys. And then also on the administrative part, obviously medical surveillance programs, because if you dive in contaminated waters like that, obviously your health is at risk. I hope that answers your question.
Okay, thank you. So last question for the session from Bridget, please.
So it's not really a question, it's just a thank you to Fani and to Luke. But Luke, that's quite fascinating. I just wanted to share that we have noticed over the years, because we deal with divers, I'll call them neurodiverse in some ways, but we have a lot of ADHD people And, and we found that their parents even come back and say when they start diving, there's such an improvement in their ability to focus. So I don't know whether it's the helmets and the limited peripheral vision that increases their recognition speed and manual assembly, but it would be interesting to have a chat with you regarding that. And also the effects of the HRV, the heart rate variable, and the divers. Yeah, so very interesting. Thank you.
Good. Okay, thank you for the comment. Okay, so again, I think, can we give all of our three speakers from the afternoon session a hand, please? And I'd like to invite all three of them up, please. They will be receiving a token of thanks from our OHS specialist from KZN, Mr. Sandile Kubeka. Yeah, so as mentioned yesterday, we are government, so we don't pay people, but we can at least give them something to for their effort for getting here. Fani is local, you saw. Bo is all the way north, and yeah, Luke is from another province. So yeah, they all had to take time out of their busy schedules to get here. So we really appreciate all the effort as well as the preparations of their presentations. Okay, for today. So thank you. So just as my last powers of outgoing program director, we have a lady connecting from the east coast of Australia for her presentation at 2 o'clock. So add 9 hours, so it's quite late for her. So I know it's only 2:15 now, but if I can appreciate if we can all be back at 5 to 2 so that, yeah, we can start at 2 o'clock for her convenience. So thank you again for the journey today, and yeah, we'll see each other after lunch. Thank you.
So good afternoon, everybody. If those who are still outside can start finding their seats, please. Okay, good afternoon once again, everybody, and welcome to the most exciting part of this conference. Thank you for joining us. I hope you all enjoyed a nice lunch. So we've been watching the fish eat, and the fish has been watching us eat, so all is well in the world. So we're going to get started with this afternoon's program, and the first presenter joins us at a very uncomfortable hour from Australia. So we're going to get straight into it and let her get on with her life after this presentation. So we are very happy for Amanda Strodels for joining us and giving her presentation on mental health and inclusivity in the diving industry. So good afternoon or good morning, Amanda. So Amanda is ADAS Executive Director. She has 13 years of experience as an occupational diver, supervisor, and diving safety officer. She has worked across various sectors, including offshore construction, inspection, onshore construction, aquarium, zoo, and scientific diving. She has 2 master's degrees with experience in training, development, and delivery. She also contributes to the IDRCF and EDTC meetings. So with that, Amanda, I'm going to hand over to you to take us through your presentation. Thank you.
Thank you very much for the introduction. I'm just going to check that everyone can hear me. If anyone can tell me whether there's any audio issues.
Can you, Amanda?
Okay, that's great. And can you also see what I'm sharing? Can you see my PowerPoint?
Yes, we can.
Okay, that's great. Okay, so, however, I can't see. Oh, yes, I can. Okay, perfect. Takes a little bit of juggling here, but I think it will work. Okay, just let me know if the PowerPoint is not working as it should. Okay, good afternoon. It's the middle of the night for me. I'm really very pleased to talk to you today about mental health in our industry and give you a bit of an overview of what inclusivity could and can look like. So I'd like to start by taking us back in time. In the 1970s, the diving industry, particularly in the offshore sector, was a very dangerous industry to work in. Fatalities were far too common. In 1988, Piper Alpha actually acted as a wake-up call. Industry leaders instigated a huge push at that point to shift to a culture of safety. This took concerned, sustained, and collective effort. And notably, it included a top-down approach where industry leaders publicly said, "Time out for safety," in order to show their willingness to spend time and also money addressing safety issues and developing safer methods of work. 40 years ago, serious accidents were very common, and there was a lot of stigma associated with whistleblowing for safety concerns. But today in 2024, the picture is very different. Everyone assumes that they will come home safely at the end of their day, and the culture has changed to no blame reporting. Of course, accidents still happen, and they always will, but globally, our industry has seen very significant improvements in work health and safety. We should all be very proud of the amazing improvements of the last few decades regarding the physical safety of our workers. But my presentation today will focus on the next challenge that is presented to us in my mind, and that is the care that we have to give to our workforce mental well-being. Mental health is a growing focus for industries around the world. Many developed countries now mandate the inclusion of psychosocial hazards into all risk assessments. I think our diving industry needs to move on from only focusing on physical hazard and establish what I call an inclusive culture of care. These, of course, may feel like buzzwords to you, but they will definitely mean something to the youngest generation, who is also the workforce of tomorrow. So first, we'll consider what it is that we mean by mental health, and particularly how it relates to offshore work. After this, I'll give you a brief overview of neurodiversity, and I'll then consider how different generations have different expectations on these matters. And I'll finish by giving you an overview of what can be done from a practical perspective to increase inclusivity in our industry. So first of all, it is always good to make sure that we're talking about the same thing. And I would like to start by giving you a brief definition from the World Health Organization. And that is that mental health is a state of mental well-being in which every individual realizes his or her own potential. They can cope with the normal stresses of life. They can work productively and fruitfully, and they are able to make a positive contribution to their community. Of course, mental health is not a completely black and white thing. It exists on a spectrum, just like physical health. Mental health varies from day to day, but it can also vary on a longer time scale throughout our lives. But crucially, mental health is very important for us to live fulfilling lives. It means that we can bring our best selves to our work sites. It also means that we can make a contribution to our communities. It's also important to note that employee mental well-being has been shown to directly affect productivity. It can affect staff retention, and it can also affect physical safety. Of course, it also affects the employer's reputation, as we live now in a society where everyone can share their employment stories with others, including on public platforms like social media. So beyond the moral drive behind taking care of people's mental health, it is definitely in the employer's interest to take care of staff's mental well-being, because it does affect the bottom line. I'll just quickly present some statistics to you that may feel maybe a little bit scary and confronting to start with. Statistically, a quarter of us will experience a mental health issue at some point in our lives. Mental health issues affect both men and women, young and old, rich and poor. Depression and anxiety are the most common mental health issues. And those two issues probably very often go untreated, as there's still significant stigma associated with talking about mental health. The European Network for Workplace Health Promotion showed that common mental health problems in 2023 have accounted for 60 million lost working days each year. The cost to the employer through loss of productivity due to mental health problems is actually higher than that caused by most other health problems. But unfortunately, those issues are also on the rise everywhere in the world. And as we know, the COVID pandemic probably had something to do about that. But what I'm trying to show you here with these pretty dark figures, I guess, is that you can expect that at any given point, there will be a portion of your workforce dealing with mental health issues. Those suffering from mental health issues cannot be excluded or treated in isolation from the workforce. In fact, they are your workforce. Next up, I would just like to touch on how mental health and offshore work can coexist. As you know, offshore work is a very unique environment where a number of factors can have a direct influence on mental health. I will attempt to present here the factors that are specific to offshore work and that have been shown to have a direct effect on workers' mental health. That can be either that these factors will contribute to the development of a mental illness, but they can also just be exacerbating factors and worsen existing mental health conditions. My PowerPoint is not... there we go. First of all, isolation. Isolation is an obvious one, and it is probably the main psychosocial stressor offshore. Workers are physically separated from their family, their community, and the usual informal support networks that allow them to digest the stresses of the day and fill their cup, as we say. Offshore workers are often away for long periods of time, and that can lead to feelings of loneliness and isolation. I'd also like to touch on the concept of cultural isolation, which is a really important factor for expat workers. Our industry relies on an international workforce, and a recent study has actually shown that expat workers suffer from anxiety and depression at greater rates than local workers. This is because expats are removed from their culture, their food, their religious habits, and all of these interpersonal communication etiquettes. I'd like to touch on the lack of privacy and the confined work and living spaces. I've grouped up a few issues together here, but they all relate to the blurring of lines between the personal and the professional. This can increase the potential for conflict between people, because the people who work together during the day are also the same people who see each other at night when their shifts are over. And this means that any tensions between them that have built during a shift cannot easily be walked away from after the shift. The physical proximity between workspaces and recreational spaces can also create blurred lines, which can make it very hard to switch off after a day's work. For most people, co-workers and friends are two distinct groups of people, obviously sometimes with some degree of overlap. We know that people tend to open up differently to different groups of people, and we all know that we put on a brave face at work, only to allow ourselves a bit more vulnerability in our private lives. In other words, we don't tend to bring our true selves to work. The lack of distinct social groups between work and rest makes it harder to access those more vulnerable conversations, as the people who are there to have them with are also our co-workers. Next, the low control over our own job. In a Norwegian survey, offshore workers have reported feeling like they do not have control over their jobs, that they cannot influence decisions which are important to their work, or indeed have much influence at all on the way that they perform their job. Low control over one's job is actually linked to high rates of anxiety in workers. Next up, sorry, my PowerPoint is doing things on its own. I'm very sorry. Next up, shift work. It is generally accepted that shift work is linked to increased levels of stress. Work has been done, research has been done to understand how different shift rotations can affect our stress levels. And it seems that the shorter rotations results in more stress levels than longer ones. 28 days on and 28 days off actually seems to be the best in terms of mental well-being. Hazardous work. Obviously, offshore installations are hazardous places. A main focus of almost all of the jobs offshore is on physical safety and the mitigation of those risks. As a result, offshore workers are fully aware of all the dangers that surround them. Working in a dangerous environment obviously can increase stress, but the awareness of those dangers around you can also lead to increased anxiety. Macho culture. The proportion of female workers offshore varies greatly between countries, roughly between 3% and 8%. On offshore work sites, like other male-dominated spaces, there is still a lot of stigma associated with talking about psychological or emotional distress. Workers in male-dominated industries are more likely to believe that it is necessary to endure pain and conceal mental health issues to display toughness, reliability, and prove their worth as an employee. A recent Australian study has actually established strong links between masculine workplace cultures and increased likelihood of mental health issues. And last but not least, environmental conditions. The lack of access to nature offshore and the direct exposure to potentially extreme weather events have also been linked to high levels of anxiety. What are the consequences of all of these factors on the mental health of offshore workforce? Well, in 2021, a research was undertaken in Australia to understand better the mental health of offshore fly-in fly-out workers. And as you can see here, the study showed very clearly that fly in, fly out workers have worse mental health than the general Australian population. And obviously COVID made that even worse still. As you can see here, fly in, fly out workers are 3 times more likely to be experiencing very high levels of psychological distress than the rest of the Australian population. And in another country, in Norway, in 2022, a survey has shown that 60% of anxiety issues and 73% of psychological problems occurring in offshore workers were directly job-related. So the data that I just presented to you shows that a significant proportion of offshore workers experience mental health issues at work. Well, combined with an industry culture that does not encourage or value emotional openness, it is not very surprising to see here that offshore workers are 15 times more likely to die by suicide than those working on onshore installations. This is confirmed by data from the International SOS Foundations, which shows that 40% of shift workers overall experience suicidal thoughts while on duty. I hope this hasn't been too heavy. Now that I've given you a broad overview of mental health, I will move on to a different aspect of inclusivity. I would like to discuss neurodivergence with you and give you a brief overview of what I mean by that. So neurodiversity, I don't know if you've heard the word before. Neurodiversity is what we call an umbrella term. It's not a medical term, and it's a term that includes a number of developmental disorders or brain disorders that have a very direct effect on a person's experience of the world around them. People who are not neurodivergent are called neurotypical. And it's important to know that neurodiversity is a very natural variation in human population. Neurodiversity is driven by both genetic and environmental factors. And it is estimated today that about 15% of the world's population exhibits some form of neurodiversity. I will just give you a very quick overview of the kind of conditions that we have under this umbrella. First of all, ADHD, you might have heard about this, autism spectrum disorder, bipolar disorder, dyslexia, dyspraxia, OCD, personality disorders, and Tourette syndrome. What I will do now is just quickly give you an overview of the 3 most common ones and tell you what symptoms they might exhibit to the outside world. So first up, we have dyslexia. Dyslexia is a condition that will affect people's ability to manipulate and differentiate the sounds and the letters of language. It is hereditary, meaning that it is genetic, and it is the most common neurodiverse condition. It's often diagnosed in children as it can affect people's ability to learn how to read at the same pace as everyone else. But however, it's important to say that the vast majority of adults with dyslexia actually do not know that they have the condition. People with dyslexia are often visual learners, and they can really struggle with some fonts. Some fonts have actually been created specifically to help dyslexic people read more easily. Next up, ADHD, or Attention Deficit Hyperactivity Disorder. There are 2 main types of ADHD, the inattention subtype and the hyperactivity subtype. The inattention subtype includes people who may have trouble completing tasks, get distracted very easily, they will struggle to stay focused, especially on tasks that they find challenging. The hyperactivity subtype will include people who tend to fidget, who cannot seem to sit still, who often overshare on a first meeting and do not work very well with boundaries. ADHD can actually have a variety of symptoms, and some adults can be very good at masking those symptoms. It is estimated today that around 1 in 20 Australians has ADHD, which makes it one of the most common neurodevelopmental disorder. And the third one is autism spectrum disorder. I'm sure that most of us, when we think of autism, we think of those really severe cases. But it's important to understand that autism exists on a spectrum. It's quite unlikely that you will ever encounter people on diving sites that are severely autistic, level 3, because this is typically associated with people who are not verbal and who will require very serious support. However, I'm sure that we can all think about maybe sometimes that we have worked with people with mild autism. You might have also heard the word Asperger's. Asperger's is typically associated with those symptoms that you can see here on the slide. People with mild autism might have communication difficulties. They can't do chit chat. They feel quite anxious socially. They will have very niche interests. They might be very overwhelmed by stimulus. Again, it is estimated that around 1 in 100 people in Australia has autism, so it is relatively common. I'd like to finish up this very brief overview of neurodiversity by sharing this really interesting fact. Blue-collar industries, such as ours, may actually have a higher representation of neurodiverse people. A recent study in the UK showed that 1 in 4 construction workers consider themselves to be neurodiverse, and 17% of construction workers have a formal diagnosis, which is much higher than the national average. And interestingly enough, when those people were asked, they declared that being neurodiverse made them more likely to want to work in construction, not less likely. So that concludes neurodiversity, and I would like to take you now to a slightly different topic again, that of generational shifts. In order to understand and to care for our workforce better, it is important to be aware of generational differences. Different generations tend to have some common values, some common opinions and expectations due to the fact that they grew up in a similar economic and social context. Boomers, born between 1946 and 1964, typically have very strong work ethics, but they're not that great at using computers. They also tend to be less aware of issues around inclusivity and mental health, because these topics were just largely absent from the public debate back then. Gen X were born between 1965 and 1980. They tend to have really strong communication skills. They can work independently. They don't need close managerial supervision. Millennials are born between 1981 and 1996. They're the first generation to use technology for their whole life, and they're more likely to enjoy meaningful work. They're conscious of issues around diversity. They know what feminism looks like. And Gen Z, the last one in the slide, is the youngest generation. Those are born close to the turn of the century, and they're just starting to enter the workforce now. They are totally digitally fluent. They value flexibility in the workplace, and they can sometimes expect work to fit around their lives, not the other way around. Right now, the world's workforce is made up predominantly of boomers, Gen X, and millennials. Boomers are obviously coming to the end of their working lives. You can most commonly find them in senior management positions. Gen Z, however, is just starting to enter the workforce, and it will soon be a significant proportion of it. I'd like to now focus on the expectations that these different generations have on their workplace. There has actually been significant research in that topic, trying to understand what different generations expect from their workplace. And this is interesting because looking into this can help us understand some of the conflicts that we'll find in workplace, the misunderstandings, the frictions. Supervisors, trainers, superintendents, OIMs, they're predominantly boomers, and they may not understand the expectations, the priorities of Gen Z. We have all heard the terms woke or snowflakes, mostly used pejoratively, but this can also be a symptom of simple generational misunderstanding. Gen Z, for example, they do consider soft skills, interpersonal skills, to be very important. They take mental health very seriously, and they will expect that others around them do as well. They know what a fidget toy is, and I can assure you that nothing in that neurodiversity presentation was new to them. But managing people with a view of integrating mental health and well-being also means understanding another generation's world. And by this, I mean their language, their values. And it means trying to create a workplace that takes their expectations into account as well. I will finish by considering what it would look like to encourage greater inclusivity and better mental health in our industry. I'll have a look at a few practical suggestions, first at the industry level, and then we'll focus on the training stage. At the industry level, a few things can be done. In countries where WHS laws don't yet include mental health, industries can definitely lobby their government to open that conversation and come into line with more progressive countries. Additionally, charters are a very powerful way for industries to establish a benchmark. Charters can provide companies with a structure on how to approach the problem of mental health at work. This can be very useful because individual companies may not have internal resources that are big enough in that area. In 2023, the North Sea chapter of the International Association of Drilling Contractors actually hosted a mental health in energy workshop, which sort of ballooned and eventually resulted in the creation of the Mental Health and Wellbeing Charter. I won't read it all to you here because it's quite wordy, but it is actually publicly available online, so you can have a look. It focuses on 10 key areas. And 30 companies are now signatories to this charter, and it's been increasing every year. More and more companies are signing up. There is, however, a common thread running through these 10 points that are on the charter, and that is one of interpersonal skills, training, and education. As I explained just a few minutes ago, Boomers and Gen X are not as familiar with issues of mental health and inclusivity. And I think in order to close that generational gap that I discussed earlier, we actually need to proactively teach our workforce the skills required to listen and to support and the right words to use. This will lead me nicely to focusing on the changes that we can implement during the training of our divers, something that I'm quite passionate about, being a diver trainer and the CEO of a certification and training organization. So what can we do during training? As we all know, I hope, change starts with education. When people train to learn a new job, they get their first taste of industry culture. During their training course, they will consciously and unconsciously assimilate the behaviors and the attitudes that will be expected of them as divers in this industry. A significant proportion of us will remember, I'm sure, stories from our own training where people talking about their emotions were ridiculed, shut down, or ostracized. I'm almost certain as well that some of you would have witnessed bullying and abusive behaviors during their training. As society's attitudes towards mental health has changed in the past 20 years, the social interactions have also improved in our training centers. The new generations of students, the Gen Z, come in expecting better communication, better care for their mental health, and an awareness of neurodiversity. If we want to meet those expectations and implement lasting change in our industry, we must think very specifically about what can be done proactively during the training. ADAS, the Australian Diver Accreditation Scheme, is one of the world-leading hyperbaric certification schemes. We train divers in Australia, New Zealand, Singapore, Malaysia, Turkey, and Spain. We have decided quite proactively to focus on 3 areas to do our part in navigating the shift towards an inclusive dive industry. First of all, students must have a clear understanding of the behaviors that will and will not be tolerated in our industry. 2, our students must be able to have support at all times if they're struggling during their training. Diver training can be very stressful. Some of the stresses specific to offshore work that I discussed earlier are also present during the training. And last, We think that we should provide neurodiversity awareness training to every single trainer during their instructor training course. And I'm just going to touch on every single one of these points in the next 3 slides. So first of all, the interpersonal skills assessment. I'm not going to read it out to you. I don't know if you can read that on your screens. I'm also happy to share it with anyone who's interested. So ADAS has created a new assessment tool that specifically focuses on people skills. This actually came from a brainstorming session following a harassment incident between students at one of the ADAS schools. I flew out to the school for a hot debrief, and one of the trainers there noted that it was really hard for them to manage student behaviors because there were no clear guidelines from ADAS. We knew that offshore contractors and other dive contractors had developed their own benchmark for behaviors, so we set to work and we created our own. And now every single ADAS student is assessed against those criteria. Failing to meet these behavioral criteria also means failing the course. So we're now confident that all new ADAS graduates have the capacity to behave consistently with the industry expectations of today. Secondly, we have created a women mentoring program, which is available to all female students during and after their training at an ADAS school. This allows them to be connected with a mentor, a woman with 10+ years experience as an occupational diver. We know that for members of minority groups, such as women or LGBTQI people, integration within the diving workforce can be very difficult and become a source of stress. Providing support for them from the start is a way of showing our commitment to inclusivity. Currently, less than 1% of all ADAS offshore divers are women, and many new women divers give up soon after they graduate. We know that peer-to-peer support can provide valuable guidance during the early stages of a career, as well as a sense of hope that other women have indeed made it in this industry. It's also worth noting here that workplaces with gender parity have greater employee satisfaction. They also have higher staff retention and higher productivity. So clearly, it is in our collective interest to make sure that we keep aiming to integrate more gender diversity into our workforce. And finally, inclusivity training for trainers. All the new ADAS instructors will receive a 1-week-long mandatory training session. And that's delivered directly by myself, as well as an external consultant. Over the years, this instructional program has evolved to move away from purely technical topics. And now the interpersonal skills assessment has become a focus. We get our trainers to work through exactly how they will present it to their students and the role that they can play in making sure that there is a psychologically safe training environment at the school. I have also integrated topics from mental health first aid as well as neurodiversity awareness to the curriculum of that particular training. And this has actually been very well received. Those sessions are steadily the highest rated in our feedback. This brings me to the end of my presentation, and I just wanted to share an additional thought. I know that you've actually already seen that hierarchy of controls today, and I'm sure that you're all very familiar with it. But I'd like to remind you that when it comes to mental health, we actually have been relying all too often on employee assistance programs to mitigate the risks associated with mental health issues. But it's important to remember that EAPs, employee assistance programs, are the exact equivalent of PPE. They're a treatment, a last resort, and should not be the first port of call. The time has come for us to focus on promoting inclusivity by implementing solutions to reduce the stresses that affect our workforce's mental health. So instead of ending with some statements, I would like to end with some questions for the industry leaders that are in the room today and others. I think everyone should ask themselves, do I treat employee mental health as a priority? Do we collectively address toxic behaviors? Do we strive to create inclusive workplaces? Are we trying to reduce stigma around mental health? And are we holding each other and other leaders accountable? That's all from me. Thank you very much for your attention.
Thank you very much, Amanda. As we all know, and something we've come to accept, that knowledge is power. So thank you very much for that information on diversity elements that we can look out for in all our industries. And thank you very much for a sneak peek at the tools that ADAs actually use. That was very interesting. I'm going to take three questions for Amanda. While we know that we've got a relatively good connection with her and we can hear each other, so let's abuse that situation. If there are any questions for Amanda, if you can indicate, we can get a mic to you. Nothing? Okay, Amanda, I think it looks like your presentation was very clear and understandable to everybody. I'm happy to say, so thank you very much. You're welcome to stay online, but should you need to go, we understand that, yeah, there is a bit of a time difference. Thank you very much.
Yes.
So the next two presentations and the last presentations for today is from Dr. Meintjes, Jack Meintjes, and yeah, he's going to talk to us about the impact or the understanding of effects of pressure and gas toxicity and unpacking hydrobaric medical operations. So Dr. Meintjes is a specialist consultant in occupational medicine and head of the occupational medicine at Tygerberg Hospital. He previously worked as a diving medical officer at the South African Navy. After leaving the military, he pioneered formal diving and hyperbaric medical training at Stellenbosch University at honors and master's level. He is currently medical director for the International MedOx and Diving Alert Network South Africa and a consultant on call for DAN Europe and DAN America, and deals with approximately 3 serious diving incidents per day. He serves on the Diving Technical Committee. Internationally, he serves on the Diving Medical Advisory Committee and has published numerous medical journal articles on the topic. So with that, I'd like to welcome Dr. Meintjes to the podium, and yeah, thank you very much.
Thank you. Thanks for having me. It's quite an honor to be here today. Let me just share my slides. There we go. So I've been asked to do two talks this afternoon, but after listening the whole day, it's become clear that the integration of the first topic into the second one, because they actually talk to each other as a risk factor in the workplace, and then how does that then feed into the hyperbaric programs? So I will actually include the first topic in the second one, and just talk to everything in an integrated manner. Now, the context within which we are talking here, the occupational health and safety, obviously this comes from the constitution of the country, which is just a one-liner, and it says everybody's got the right to a health and safety environment. Now, that one-liner obviously is unpacked in terms of a number of different acts. In our context, we're talking about the Occupational Health and Safety Act. But once you start working in the diving industry, you find that once you start diving diamonds on the West Coast, there's the Mine Health and Safety Act. And once you get on the vessel, SAMHSA gets involved. And once you have flown off the rig at Mossel Bay, then the Civil Aviation Authority gets involved. So there's actually more than one act involved. And each of these acts have got a whole set of regulations that speaks to that act. And each regulation, each of them might have a number of codes of practices and a number of technical assistance guidelines that follows on them. So it actually becomes quite a complex system within which we are working in this sector. So the context that I want to talk to, or that I've been asked to talk about this afternoon, would be the difference between the level 1 and the level 2 doctors that we're talking about. So with the level 1 doctor, you go to the doctor, you get your diving medical examination, and he declares you as fit to dive. That's your diving medical examiner. In our context, it's a designated medical practitioner, or a DME internationally, or in the UK, it's called an AMED, versus the person that actually provides operational support to the diving operation. Is actually part of the company, so to speak. In our legislation, there's a requirement for contracting directly with such a person. And the question is then, what is this role and the need to have an occupational medicine qualification? Now, when you read the Act defines occupational medicine, but occupational medicine is actually a specialist medical discipline, like you can become a gynae or an orthopedic surgeon. I've specialized in occupational medicine. It's a formal qualification where we deal with patients at risk for illnesses that is work-related, but also with patients where this risk is realized. So they've actually gotten ill as a result of things that occurred in the workplace. The legal definition is actually coming from the Occupational Health and Safety Act. Occupational medicine is defined as the prevention, diagnosis, and treatment of illness, injury, and adverse health effects associated with a particular type of work. Now, the particular type of work we're talking about today is, of course, diving. That's the topic of the day. Now, in diving, everybody thinks about pressure. Pressure is the risk factor. And this is typically addressed by most when we go for a medical, etc. Are you fit to dive? Yes or no? But there are various other risk factors that also exist, and this has been covered in the previous presentations. And these are present in all workplaces. That can be while you are working underwater, or it could be on the surface. You might be working at heights, and it might include the support crew. It is not just the divers that might be affected by these conditions. And when we talk about risk management then in diving, this occupational health service that is rendered in the workplace is based on the risk factors that are present at work. And this is just part of the overall risk management process of the diving company. It looks at the health risks as part of the other risks. And in general, if we then have to look at the difference in the doctors that are involved here, if you look at the way that we normally would interact with a doctor is, in clinical medicine, is the doctor sits in the office and he waits for a patient to get ill. And once the patient gets ill, the patient comes to me in my office with his illness or with his injury, and I see him at my facility. You come to me at the hospital, and I diagnose you, and I say, yep, you've got this illness, here's your prescription, and I treat you. So it's a curative approach. With occupational, and of course we're working with individuals, with occupational medicine is we don't work at the doctor's office. We work at the workplace, where we go and we say, well, what are the risk factors in the workplace, and what can we do to prevent the person from getting ill? And you can see it's a preventative approach. And we're working with populations. If I see an individual with an illness, the question is what can happen to the other persons? So we're working at a population basis. We're not trying to get a single individual when we do screening and surveillance in that context. So the overall management of the risk is then based on, and you've heard this numerous times before, it's based on the hazard identification. You risk assess and you quantify it with the industrial or the occupational hygienist, and then you control that risk or eliminate the risk, and then the medical surveillance program for the risks that still remain, that you cannot engineer out and you cannot manage with all the admin controls, etc. And we've published this textbook regarding medical assessment for work under pressure. So this is the new fitness standards internationally. It was published about two months ago or so. And I was asked to be one of the editors of this textbook. And you can see that one of the chapters actually addresses this issue. So it's not just about whether you are fit to be exposed to pressure, but it's are you actually fit to be exposed to what else? Physical, chemical, biological, ergonomical, and psychosocial hazards. So we assess the risk of each, and then you ask the question, do I need to have health surveillance for these other things that I'm exposed to? Not just the pressure, but there are other regulations as well, not just the diving regulations. So it starts all with the hierarchy in the workplace, not at the medical facility. Now, hazards obviously are present in all workplaces. This is not unique. We're not talking about something that's now unique to diving. So the definition of a hazard, of course, that's any agent, activity, or situation, or a substance, anything that can cause harm to the individual. Now, what do we mean with harm? It can be a health hazard, it can be a safety hazard, hazards to the environment, and you've seen many presentations throughout the conference this far that talked about the safety hazards. Our main concern as medical practitioners are the health hazards. So what are the things that can cause illnesses, diseases, not injuries in the individual? And you can see, as I said, this is part of the overall risk management process. So it typically falls within SHIRK department, safety, health, environment, risk, etc. So safety, yes, where you can get injuries, etc., that's one compartment, but health is included in there. So step one, I would go to the workplace, I would identify the hazards. So health hazards would be things like noise and vibration and heat and cold and ionizing radiation, etc. Various chemicals, I can't even list them all here. Biological, ergonomical, psychosocial hazards. The question is, are those hazards real risks? Because the mere presence of a hazard doesn't mean that I need to do a medical test, purely because this thing is present in the workplace. So the risk assessment, let me give you an example. This is an email from one of the diving contractors. So, dear Dr. Jack Mankies, please see attached the following for your perusal. I've included the dive plan, which makes reference to other procedures and dive tables, etc. Currently, we are tasked to unblock, clean, and replace the fusers at the southern outfall. We're using the following tables, DCIM, etc. And you can see there's the diving project plan, mixed gases, the diving operations on the metro pipeline, general diving operations, the emergency response evacuation procedure, the medical emergency flow chart, and HSE management plan, HSE, health, safety, environment. And you can see these are documents each with hundreds of pages. And as a level 2 DMP, I'm part of this process and saying what here is going to make the person ill. And this starts right as in the planning of the project already. So assessing the risk, and if we then assess the risk, the question is, well, who is going to be exposed? How are they exposed? Divers would know. To be exposed to alcohol, you don't absorb alcohol through the skin. You don't inhale alcohol. Alcohol is absorbed best via the gastrointestinal tract. And therefore, you might find chemicals in the workplace that if you read up on the internet, everybody would say, well, this is very dangerous. But if you look at a diver's got a separate gas supply from which they breathe. So they're not going to inhale this chemical. They're not going to drink liters and liters of water while they are diving. So what are the chemicals that we are concerned about? It's something that can be absorbed via the skin if they're diving with a wetsuit. Does that make sense? So how are they exposed? Do we need some exposure measurements? So do we need to get the occupational hygienist in to come and measure the noise levels or other levels of a substance in the environment? And then if I know this is what they are exposed to, I look at this and I say, if I expose you to this, you're going to get a disease. And the question then is, what are the outcomes that I expect with this exposure? And we plot that on the risk matrix. Just like we do with the safety aspects, we do exactly the same, but now we're talking about an illness, not about an injury. And this can be cancer occurring 10 years down the line, not necessarily today or with this dive, but 10 years down the line. Now, we go through the same processes of risk mitigation, elimination, substitution, engineering, admin, PPE, those sort of things. And if we cannot manage that risk to acceptable levels, then we need to say, if I expect this person to get a disease because of this exposure, we need to do medical surveillance for this. This has got nothing to do with your diving medical. We know you are fit to dive. But this illness, because of this exposure, is something that we need to do medical surveillance for. And this is a planned program. So you're going to be here for your medical, your diving medical every year, but do we need to include other tests? So clinical examinations, biological monitoring, or medical tests that are required because of this. And this can be body fluids, tissues, excreta, exhaled air, or something to detect or quantify exposures, or we look for disease based on what's happening in the workplace. And that will give us feedback. It will tell us, yes, the hazard is here, or yes, this is a high risk, or our risk mitigation is not working. You said that you are mitigating the risk, but when I draw the bloods, I see there's still a lot in the person's blood. It's not well controlled. So we can give feedback to the employer regarding the exposure, and this reporting system going back to the employer. And that's basically the theory and my introduction. So let's get practical. Let me show you some examples. Now, there are two approaches to this. We obviously start with our main hirer, and that is, as our occupational hygiene colleagues said, anticipation. If you are a police diver and you know I'm going to dive in certain areas, you know what's going to be there. I can anticipate this is going to be in the water. And these are the typical risks that people are going to be there, and this is part of our routine work. And because I know it's going to be there, it's part of my HIRA already. And then there is the updated HIRA that I do on the day. When we get there, we see, whoa, we did not know this is going to be here. People are now throwing chemicals in the water, and this is not something that we foresaw. And this is the particular project or task that we see on the day. And for the health side, we look at these 5 categories: physical, chemical, biological, ergonomical, and psychosocial. So let me just give you some examples. Physical hazards: pressures, temperatures, ionizing, non-ionizing radiation, noise, electricity, those sort of things. So pressure, this is the one we know best. And this is what we do the diving medicals for. So you already get the medicals for this one. Boyle's law, those sort of things. With pressure, we get changes in our physiology, and we also know that it increases contaminant partial pressures. So carbon monoxide at the surface is not the same as carbon monoxide when you breathe it at depth, as an example. And all the illnesses associated with that. Barotrauma of the ear, yes, that's what it looks like if you dive without a mask that includes the nose. So swimming goggles. So that's eye squeeze. And lung barotrauma, gas embolism of the brain, those are the type of things that we see with barotrauma. But heat, burns, burn injuries, and things that we might have in our emergency kits. But what if you dive in very hot environments? If you dive, for instance, in nuclear fuel rod storage pools, the water temperature there is 35 degrees, and you can get hyperthermia if you are diving there. Ionizing radiation. So many divers actually use ionizing radiation if you are doing non-destructive testing on welds. In our setting, in the South African mining industry, the heavy mineral sand deposits has been mined for many, many years, and there are many radionuclide impurities there. And this low level but consistent exposure to radiation is actually present in those areas. And this is up on our west coast. This is well described. In fact, if you go to the beach today and you just dig there, you will be able to see the lines in the sand of the heavy sand that is in there. And this is what the people are mining. So the zircon, ilmenite, and rutile, these are the things that are being mined there. And if you read the literature, they say the Namako Sands heavy mineral deposit is by global scales the largest in its class, boasting applicable value mineral sources that could potentially sustain mining for several decades at the current production rates. And you might have these naturally occurring radioactive materials in places where we dive. In the drilling mud offshore Mosgas, there's radioactive vanadium. You get radon gas and radium in many of the mines, if you do a project in one of our mines. And you get even tenorms, technologically enhanced naturally occurring radioactive materials, that they are concentrated through the industrial process. And that's if you work, for instance, in the Richards Bay area, where they are mining these sands, or up on the west coast, where they are mining these sands. And I've had calls from divers that needs to go and dive in these dams, where they then concentrate these radioactive materials, and they need to go and fix one of the valves on the dam. And now the diver's going to dive in radioactive material. So do we need to do a medical for that? Or? No, you've had your diving medical. Non-destructive testing in general. There might be stochastic and non-stochastic effects associated with that. So the stochastic effects where there's no threshold for exposure are things like cancer that you can develop. Now, that's not going to present during the dive. It's coming years down the line. And then the non-stochastic effects is the radiation burns injury. So the photo that you see there is a person that actually took a radiation source and he put it in his pocket. And he walked around the whole day and he forgot he's got this radioactive thing. And he got this radiation burn in his, on his chest. Where do we get the guidance for the medical surveillance for this? This is actually based on the IAEA recommendations. And this is regulated in South Africa by the NNR, the National Nuclear Regulator. There's also the Department of Health, the Hazardous Substances Act. The Department of Labor obviously plays a role, but there are no regulations for this. But it is a workplace. And the Occupational Health and Safety Act would apply, that you must do a risk assessment, and the risk must be managed. And the same with the Department of Minerals, Resources and Energy, so the Mine Health and Safety Act. And you need to have a doctor with appropriate knowledge and qualifications that knows about these stochastic and deterministic effects and which organs are going to be affected if you dive in these sort of environments. And actually, just like you get a designated medical practitioner to do a diving medical, you need to be an appointed medical practitioner if you work with radiation. And there are specific requirements for the medical surveillance. That is regulated by the National Nuclear Regulator. So the medical that is being done, All of these things are actually prescribed. That's radiation. Let's look at noise. In terms of noise, there are various sources of noise in divers, and it's been spoken about before, but you can see here in this UK document that was referenced earlier as well, breathing noise generated by gas flow through the regulator demand valve and self-generated breathing noise is a major contributor to divers' noise exposure when wearing diving helmets. The noise levels in diving helmets increase with increasing diver ventilation rate, with helmets producing exhaust bubbles presenting higher noise levels than those that did not. Communications and flushing through also create high noise levels, and those exceed the exposure action and the limit values. So divers are exposed. So noise exposure in the helmet and the requirement for those things. But it's not just while you are diving. As you know, divers don't just spend all their time underwater. You are also going to operate the grinder at the surface, and you operate the compressor and all the other areas where there's also exposure to noise. And noise, if you see hearing loss in divers, there's all these questions. Should this be part of a diving medical? It's unlikely that it's going to be inner ear decompression sickness and inner ear barotrauma. So why do the divers go deaf? Yes, it's my wife also, but we go deaf not because of decompression sickness and barotrauma. It's not the pressure, it's noise. And that's what the studies are showing. So it's actually not the diving regulations, it's the noise-induced hearing loss regulations that apply. And if you are exposed to noise levels above 85 dBA, then those comes into play. And you can see if the HSE also refer to the need to do appropriate comprehensive health surveillance program that involves audiometric tests for divers. Now, our regulations, they were promulgated in 2003, but just be aware that there are new regulations that are on the desk of the minister, just waiting to be signed, and they will then be promulgated. So the draft was published in October 2022 already, and I believe that they should be available quite soon. And so those regulations would then apply. What about vibration? Look at this email. Morning, Dr. Meintjes. I trust this finds you well. We are busy with the Plitco campaign. We have most of our vessels that work on this project. Our teams are exposed to having jackhammer into incredibly hard material subsea for extended times, and the personnel are reporting discomfort in their fingers, wrists, and arms. So they're already symptomatic because of what they are doing here. And just see the email from the supervisor. The supervisor is saying something is not working here. And you can see he's sending it to the HSE manager, and he says, I would like to bring the following information under your attention regarding hand-arm vibration syndrome. I feel that the below need to be looked at, as to some of the divers are mentioning discomfort in their arms and their wrists. We are currently working on the Plitco preparation, etc. And you can see that their vibration level on the equipment they are using cites a vibration level of 13.5 meters per second square for the T-handle model that they have on board. So this now is presenting with specific illness related to vibration. Now, IMCA has got guidance on this, and this is not something new. This has been available for years already. The UK Health and Safety Executive has published a report on this before, and you can see that the IMCA guidance has been provided specifically on vibration exposures to divers. And you can see there's even online videos to be used. So if the employees are exposed to vibration, they should be informed of the hazard, how to mitigate the hazard. All of these are available on the IMCA website. And we know, even on the medical side, you can see here musculoskeletal complaints amongst professional divers. Our findings suggest that divers having worked with vibration and rotating tools are at an increased risk of musculoskeletal complaints, as is also shown for other workers using such equipment. And then if you look at the medical tests that we do, so there's specific medical tests, it's called the vibrotactile thresholds, and if we do this and we compare the amount of exposure above water to people underwater, you can see that vibration exposure at 4 meters depth produced a greater temporary threshold shift than in the atmosphere, and the recovery time was also affected negatively. So it seems to be worse underwater than with the same equipment that you would use above water. Now, we don't have specific regulations on vibration yet, but again, the draft is on the desk of the minister. As soon as it's signed, these regulations would come into play again. But we can start with the medical surveillance, and these companies that have sent me these emails, we started with these medical surveillance programs based on the international standards and the IMCA guidance that have been available for years already. And you can see that this now comes from the draft regulation. So you can see there's a whole section 13 here talking specifically to vibration and how vibration should be managed in the workplace. And you can see for hand-arm vibration, the occupational exposure limit is 2.5 meters per second square. What did the email say? 13.5, way above the exposure limit. So the time that they can work with that equipment should be significantly limited. They can only work for a very, very short time, and the 2.5 meters per second square is what you can do for 8 hours. But if you're running at 13 meters per second square, your time with that equipment is going, and that's why the people are showing symptoms, is they are way over the exposure limit. And if you start showing these diseases, the Compensation Commissioner has actually published a 110-page document on work-related upper limb disorders. So this is the guidance document for employers and for medical practitioners on how this should be managed in the workplace. And you know that we use these things underwater, rotating and vibrating hand tools, all the cold cutting tools, etc., causes vibration underwater. And the illness we're looking for would be hand-arm vibration syndrome. It's got neurological and vascular components, and you can have one or the other in the persons. And some recommendations would come from companies to say broco cutting is dangerous. You've seen the example of the explosions as it splits the oxygen and the hydrogen atoms and cause the explosion. So divers should rather use these cold cutting methods. Well, the exposure to vibration. So choose the equipment carefully that you don't expose the persons to a lot of vibration. And so on and so forth. Those are just a few physical hazards. Let's look at chemicals. Again, we've got specific regulations for this, and there's a new draft again on the minister's table that will be promulgated soon. But chemicals, of course, would be anything, any physical state, solid, liquid, or gas. And this can be released even during the work activities. So painting, welding, lubricating, degreasing, whatever it is. And the toxicity depends on the type of the chemical, the physical state, the dose of exposure, the route of entry, as we said, through the skin and so forth. The individual susceptibility, do they perhaps have a disease to which this chemical would make them to react more? So here again, another email. Hi, Doc. Trust that you're well. Would you be able to review and interpret the attached water sample analysis on the clarifier tank for us, please? The big highlight they brought to our attention is the E. coli content. So E. coli content. Yes, here on the right-hand side, you can see E. coli counts are high. So can we dive with this? And I'm looking on the left and I say, there's some nickel and chromium also in here. So who of your ladies and wives, when they put on jewelry, they actually get a reaction to the jewelry? This is a very common nickel and chromium allergy. Yeah, my wife also, she can only wear 100% gold. As soon as it's less than 100%, 24 carats, then she reacts to that. You know, so I can't fake her out. It's the nickel and the chromium in there. So if a person has got a nickel or a chromium allergy, which is a common allergy actually, the person might react to this. And you can see there, they measured lead as well. Lead cannot be absorbed via the skin. You know, we've got all the diving leads and so on. But in certain cases, lead can be converted by bacteria in the water to organic lead. And organic lead can be absorbed via the skin, and you can get lead poisoning. So we want to know a little bit more about lead there. And then you see there's phenols, and the phenols are quite high as well. So yes, there's E. coli, but did you see the other page of the report? And you're going to dive in this, and there might be other exposures as well. I got this email, Doctor, I'm working with an offshore oil company. We've got kind of a situation here that includes direct contact with petroleum, and because the heat here, we don't use wetsuits. So the petroleum stucks, and this is what, I just quote him now, stucks to our bodies, and it's so sticky that we are forced to use diesel to remove it, and it hurts. So please, if you know something about it and some other way to remove the petroleum, please let me know. You'll help 32 commercial divers and the biggest oil company here. This is the photo that came with it. This is absorbed via the skin. This can cause cancer down the line. But no worries, they've already had their diving medical, so they're fit to dive. These are the contaminants in crude oil. This has been well described previously, and you can see there, asphyxiants, central nervous system irritant, may cause cancer, perhaps genotoxic to your genes. So if you want to have your children, that might be a problem. CNS depression, peripheral neuropathy, under consideration for illnesses, CNS, liver, kidneys, irritation, CNS irritation, so skin irritant, and those sort of things. And this is what you see. And then we wash it off with diesel. Well, let me just think, diesel, no, that's safe. No, using diesel to wash it off. Let's take a bath in diesel. Surely you must know that this is a hazard and this is a risk, and something should be done here. So having the right equipment, having the correct decontamination procedures in place, so the engineering, the admin, the PPE procedures, that's what we want in place. And when you wash the guy, make sure that even the person, not the diver, but the other person is also safe, because otherwise he will be exposed while he's doing the washing and so forth. Here you can see a chemical burn. So this person, the neck dam seal didn't seal correctly, and some of the chemicals during the dive actually leaked in and caused a chemical burn on his neck. This is a person where the drilling mud actually came into the boot while he was diving, and this then stayed and had contact with the skin and caused an irritant, or it could have been an allergic contact dermatitis as well. And there are specific circular instructions from the Compensation Commissioner for these diseases listed in our Act. Chemical exposures to welding fumes. You can see this person is not appropriately protected and inhaling these fumes. And I can give you numerous examples, and you know these things are happening as well. So what are the target organs? Which medical tests must we go and do? Well, it depends on the chemical. It could be respiratory system, it could be the skin, reproductive system, the blood-forming organs, hematopoietic system, neurological system in many cases, genitourinary, gastrointestinal system, or the liver, and so forth. There are many conditions that can follow chemical exposures. Now, when we read our regulations, they actually set exposure limits to say that this is the level that you can be exposed to a certain chemical. And if you are exposed above this level, then the law kicks in and there's certain medical surveillance, and below this level, you are generally accepted to be safe. But you need to read the rest of the document. It says where higher atmospheric pressures may be encountered, for example, in tunneling or underwater and hyperbaric chambers, such situation would require special assessment. Guidance may be sought in the HSE document that is quoted, and you can see the document down here. And they can say working conditions which impose additional stress on the body, such as exposure to pressures, may increase the toxic response to an agent. In such cases, specialist advice may be necessary to evaluate the effects of these factors. So the toxicity of a chemical at normobaric pressure is not the same as the toxicity while you are diving. And this makes it very difficult because now we've got regulations for the chemicals, but those regulations do not apply at pressure. You need to have specific assessments. There is some guidance from the HSE, but it's not as easy as that. It's not just a simple partial pressure calculation. You would typically look at a time-weighted average of 8 hours exposure. So you're exposed for 8 hours a day, 5 days a week. But in saturation diving, how long is the exposure again? It's not 8 hours. It's 28 days that you rebreathe the same gas again and again. So if there's any contaminant in that system, then you're going to be exposed long term to that. So the exposure limits are significantly different. And the partial pressure approach to say, let's just look at the partial pressure, that doesn't work. Just to give you an example, so this is just at the same depth. You can see for chloroform, for instance, it's a 50% reduction in the rates. But isopropyl alcohol, 400 to 1. What is isopropyl alcohol? Well, that's a little swabby that we use to clean before you put up a drip. So you cannot take that into a hyperbaric chamber at all. You cannot use that to clean when you put up a drip. We use different things in there because of the toxicity and, of course, the fire risk and things in there as well. So you can see it's not just a simple let's multiply it by the partial pressure to work out the toxicity. There's pharmacodynamic principles and pharmacokinetic principles. Let's go to the biological hazards. Macrobiological, there might be marine life exposures. We see a lot of fire coral stings, for instance, in the Middle East, in the Saudi waters, etc., that people are exposed to. Or in this case, where you can see a diver that suffered marine life injury. Diving in Africa, many of the rivers, you've got crocodiles and you've got the hippopotamus, and we actually put up a bubble curtain where the crocodiles and the hippopotamus hopefully are scared of bubbles and they don't come through the curtain. You've all heard about the seals recently in South Africa, where now we've got a macrobiological hazard carrying a microbiological hazard, where there's rabies in the seals. And you know that the seals are quite inquisitive, they come around and so forth, and we've got multiple confirmations of rabies in seals. And obviously one should have procedures in place to manage that. But coming then to the microbiological side, viral, bacterial, parasites, toxins, proteins, and so forth. And the ones that we commonly see in divers would be that we go and dive in a malaria area. We go and we get dengue fever, or we get bilharzia in our country. Diving in sewage sludge. Those are high E. coli counts, isn't it? And these police divers actually seem quite happy about it. I don't know what's wrong with you police divers. You're a different type of person. What about bilharzia? Bilharzia, schistosomiasis. So it's known as bilharzia, disease caused by parasitic worms, and it's got the two hosts. It's a little snail and the human hosts. Who gets this? It's if your skin comes in contact with fresh water. Where in South Africa? Limpopo, Mpumalanga, north and east of Gauteng province, lower altitude areas of KZN, extended along the coast into Eastern Cape Province, all around to Gqeberha. If you dive in these waters, then you are exposed to this, one of the agents that causes bladder cancer. No worries, you've got your diving medical, you're fine. How is this transmitted? It's transmitted by contact with contaminated fresh water, like rivers and dams, where the police divers typically are diving. It's described in SA Divers. There are many publications around this, and this should be included in your risk management if you are diving in these high-risk areas. So it should be included. And here you can see some of our police divers, so not just the bilharzia in the area, but they actually wear gloves that keeps the blood in contact with the skin, as you can see. So where's the hepatitis B and the hepatitis A vaccine? Exposure to HIV and splash injuries and things like that to make sure that they are adequately protected and get the right equipment for the job. And when you look at this, you say, well, yeah, this is what we do. This is our job. And from a medical point, I look at this and I say, this is not safe. You are going to get a disease, not today, but you are going to get ill because of these exposures. This is where a child fell down an open manhole, and this is the standby diver, by the way. You can see the comms box. So the standby diver is ready. You know, your police are cowboys. I knew you guys are going to be here today. And the diver is now actually searching for this body. So, of course, spot the diver and win a prize. Here is the police diver on scuba and with comms and all of that. But what is in this water? And what is the diver exposed to? On scuba, you said? Do you think you're taking anything into your mouth at all? No, not you guys. Okay. There are actually regulations covering this, also under the Occupational Health and Safety Act. As this biological agents, there might be chemicals in there as well, of course, as this biological agents regulation. So what you need to do a risk assessment, and the medical surveillance will follow the risk assessment and preventative measures according to this. From the medical point of view, if you can't manage all those risks, we look at things like tetanus, hepatitis A, hepatitis B vaccines, and so forth. And I would say specific personal protective equipment, the equipment you use to dive with, and those sort of things are things that I would take up with management. The ergonomic hazards, if you just look at the weight of diving helmets and a person that might have a pre-existing neck problem and so forth, might cause problems. And some of the awkward postures and strains that we have on the musculoskeletal systems. We know that divers are prone to get hand injuries as part of this. This is the second most common injuries in divers. The most common one, of course, ears, and ear equalization. So we have got moving machineries and equipment and those sort of things that might be safety hazard. But other ergonomic hazards would be the static and dynamic muscle loading, repetitive movements, the heavy equipment that you carry, all the things that you are lifting, the grips and the handles and the holds, etc. In fact, pain on the outside of the elbow here, like you get golfer's elbow, it's actually called, the name of this disease is tank carrier's elbow. That's the name of the occupational disease. Lifting, pushing, pulling, carrying, manual handling, the workstation design and the layout, all of these are ergonomic or risk factors, very common in diving. I don't even have to put up photos. And then the psychosocial hazards. Now, of course, when you come to the workplace, it's not just the workplace that brings the hazard. You've got things going on at home, and it's not like you just leave them there. The fact that my wife eats me is something that comes to work with me, of course, as well. And I'm using some drugs to help me cope, and this is what we do as divers. And there are some common psychological conditions that everybody just suffers from, anxiety and depression and those sort of things. And so to screen persons for these things, to see how this may impact in the workplace, is quite difficult, because just the screening questionnaire for depression is a long questionnaire, and for anxiety is a long questionnaire, and for PTSD is a long questionnaire. So we've actually did a study on this, and we published this about a year or two ago, where we developed a questionnaire with less than 50 questions that screens for a whole host of things. It doesn't make the diagnosis of any of these, but it says, whoop, this person should be seen. It just raises a flag. And this has been tested specifically for South Africa across all our official languages, 11 official languages, and we looked at the receiver operator curves for the questions that are most sensitive to identify the common things affecting the workplaces. So common illnesses, depression, anxiety, PTSD, ADHD, etc. The substance abuse that we know happens in divers in other countries, not in South Africa, of course, and so on and so forth. The typical psychosocial hazards in the workplace. So if we come to the workplace specifically, those are things like shift work and night work, bullying and harassment in the workplace, high demands, and if you've got poor job control, inadequate rest breaks, like in the offshore environment, it's 7/7. It's no weekends there. You work 7/7 on all the time. You will be off when you've got your 6-week rotation again. If you are remote and isolated work, conflict, poor relationships, and so on and so forth. And then the psychological trauma. I mean, if this is what you're dealing with, or if you're taking out the body of a small baby, or something like that, these things may affect a person. And that's got nothing to do with whether you can dive or not. It's not part of a diving medical. And if you should develop something like PTSD, there are specific circular instructions from the Compensation Commissioner for this, and this should be addressed. And if this is identified as a hazard in the workplace and a risk in the workplace, then what are the measures put in place in the workplace, the debriefing, counseling, and things that may be necessary for an individual, who they can call an employee assistance program, etc. Substance use and abuse. There was one company that I consulted with where I had some knowledge about what's happening in that workplace, and we advised random testing there, and the employer said no. Because if we start testing, we know that 85% of our dive workforce we will lose, because we know everybody is using substances. Now, of course, you need to get a policy in place to manage this. Often people have a zero-tolerance approach in companies. The procedures must be clearly described. This is how we do the tests. We will see for bloodshot eyes and walk the line and stand with your eyes closed, and if this happens, then we'll send you to the doctor for a blood test, and we'll do this and that. So those procedures and those screening tests can be done by any person, security person or a supervisor, etc., if you suspect that the person might be under the influence. And the question is whether this is a disciplinary matter, because you're not allowed to bring those things into the workplace. That's what the Occupational Health and Safety Act says. But there's also the Labor Relations Act that says that if a person has got a medical condition, like I'm a drug addict and I've got a severe illness, and why would you treat somebody with hypertension, but you won't allow me to receive treatment for my addiction? And the question is this a misconduct case, or is it a medical illness case? And legally, that's a very difficult line to follow and to have procedures for that in place. And the medical practitioner has got a very specific role in making that. So in summary, what am I doing as a level 2 doctor? It's not just about did you pass your diving medical examination. There's a lot more. And medical surveillance for these things is a planned program. Just like you go for your medical every year, we need to say, because you are exposed to these things, you need a radiation medical, and you need a vibration medical, and you need a whatever medical it is. And this cannot be done from behind a desk. It's not a diver coming to me for a medical. I need to go to the workplace. You can see the emails that came to, and we need to say what are the things that are in the workplace, and there must be a hazard identification, a risk assessment, and the doctor obviously need to know what they're talking about. They need to have this occupational medicine qualification. And the procedures to be followed, those are described in legislation. They are in the regulations, not the diving regulations, but all the other regulations under the Occupational Health and Safety Act. The common problems that we see are people that are not starting with a high run from the workplace. You come for a medical and we'll just send the people for an occupational medical. What's an occupational medical? Well, it's X-ray and lung function and blood pressure, and I think you must pee. That makes no sense at all. You have to start and say, what is the person actually exposed to in the workplace? You need to know the law and the guidance associated with each of those hazards. And the other problem is that people don't plan for the consequences of the test. You do an X-ray and you find an abnormal X-ray, and then you say, well, the person now needs to go and see a specialist and get a CT scan. And they say, well, you didn't quote for that on the medical surveillance program. You just said we're going to do X-rays. Well, if that X-ray is abnormal, the employer needs to pay for further testing. And then the difference between interpretation of a screening test versus a diagnostic test. If I screen you and it's positive, that doesn't mean it's a diagnosis. It doesn't mean you've got the disease. And that's quite difficult. So let's just briefly talk about medical screening and surveillance then. And again, this is what we've put into the new textbook. You will see that if you've done your risk assessment and you say, is health surveillance required? Yes. The question would be, is there a specific legal requirement? So are we talking about lead or asbestos or noise, and there's a specific regulation? Yes, then follow that prescription. Because the noise regulations would say, if you're above 105 decibels, you must have a medical every 6 months. And if it's diving, you're exposed to pressure, then you must have a medical every 12 months. And if it's chemicals, then you must have, and those, so you just follow the legal prescription. If it's not, and you say there's bilharzia, and we police divers and we exposed to bilharzia in the water, then you select the appropriate tests for the exposure or the effects. So then the doctor needs to apply his mind and say, how are we going to now test? Now, what are we looking for? What is the target organ? How is this going to affect the person? Who is exposed? How are they exposed? What do I expect to see? And if I then see that the person is exposed, so I'm testing for exposure, do I see that you are exposed? Then this goes back to the workplace and say the person is overexposed. But if I'm testing for diseases, and I say, oh, we actually found that you are ill, then this must be reported as an occupational disease. You got it from the workplace. So the whole Compensation Act comes into play. Or, no, not or, and I must initiate and refer you for appropriate treatment for this disease. And then the question is, does this impact on your fitness to work? Because now I'm sending you back to the same workplace again. So are you fit to dive and to go and to work with this illness without any problems? Are you temporarily unfit, permanently unfit, or fit with restrictions, or fit with conditions? Not because of the diving, but because of this other condition now. So how do we develop this medical surveillance program? So we do the risk assessment, we look at potential exposures, the routes of absorption, what are the target organs, because that will guide our testing. And then we select the test based on the specificity, sensitivity, positive predictive value, negative predictive value, likelihood ratios, and those sort of things. And then the test schedule. If it's legislated, we follow that every 6 months, or every 12 months, or every 2 years, or whatever the case may be. Or we do it risk-based. So When do I expect to see what I'm looking for? So that's the nature of the hazard, what's the natural history of the disease, and so on and so forth. And then I set action criteria. So if this test is negative, what am I going to do? If the test is positive, what are we going to do? And this is a pragmatic approach. And we standardize the testing process, so all the quality controls are in place, and we look at all the ethics. So we inform the employees, this is why you get this test. This is because of the hazards. And if this test is positive, this is what's going to happen, and we're going to do these treatments and so forth. And there must be informed consent for the testing. And once we've done the test, we give feedback to the employee and say, you tested positive or negative or whatever the case may be. And there's confidentiality issues, because now this relates to an individual, but we also need to tell the employer if there's, as a group, 3 people with a certain illness. And what do we do if we identify a work-related issue in an employee? Because that has got implications for the employer to manage the risk better. We evaluate the workplace, so the hierarchy of controls. So we revisit everything if we find a disease to say, well, this is not adequately controlled in the workplace. The employees are still getting ill. Sometimes there are legal reporting required. There must be record keeping, and we reduce all of this to a written document. And this must be reviewed by the Health and Safety Committee. That's a legal requirement. And then, of course, we might just pick up while you come here, well, you also have high blood pressure, or you also have diabetes, or something that's got nothing to do with the workplace. So how do we deal with those things? Do we send the person to their GP? Because now the employer is not responsible for that component of the illness. We also need information from the employer. To say whether this employee is fit to work, I need to know exactly what he's going to do. What is he exposed to? Do we have the occupational hygiene reports, the noise levels, and other measurements that the occupational hygienist has done? What is the PPE that this person is going to wear? Is this a police diver diving with a wetsuit, or is he going to wear a dry suit? So then I know whether I need to look for something that can be absorbed via the skin or no. The skin is adequately protected. And what is the duration of the employment, and how long will the employee be exposed? If it's just an in and out, I look at this differently than a person that's going to be exposed to the same hazard for a month and so forth. And let me give an example. So this is one of our clients. And you can see here, we start with a background and introduction. So this is just the company commitment and the legal requirements. Who are the personnel that will perform the medical surveillance, and who are the personnel requiring medical surveillance. And we divide them into homogeneous exposure groups. So the divers and the managers and the admin workers. We're obviously not going to give the admin people a diving medical, and we're not going to give the divers a radiation medical, and we're not going to, so who gets which medical? And then we look at the medical surveillance and biological monitoring program. So based on our HIRA, we had a list of, I would say, probably close to 100 to 120 hazards in the HIRA. Out of these 120 hazards that we identified in this specific workplace, there were 7 that required medical surveillance. And that was, number 1, we just look at general health. So does everybody have a normal blood pressure, so on and so forth. Hepatitis B, noise, non-ionizing radiation, specifically UV, because they're in the sun outside a lot. And, that causes skin cancer. Medical surveillance for raised environmental pressure, that's the diving medicals. And then there were cleaning chemicals, and there were some ergonomic risks for some of the admin people. And then the record keeping, reporting, updating and review, and then I sign off on it, and the distribution, who gets this. So the Health and Safety Committee, the CEO, and so on and so forth. And here you can see this is an example for hepatitis B. So we say, what are the legal references? So these are the legal references, the regulation for hazardous biological agents at that time. There's also from the Department of Health, there are some guidelines. There's a Schedule 3 of the Compensation Act specifically mentions hepatitis B. And so the medical surveillance, we will do immunity testing for hepatitis B. Who would that be? It would only be the first aiders. Why the first aiders? Well, if they provide first aid, they can be exposed to blood. And if you're exposed to blood, you need to make sure that you are immune against hepatitis B. And so we would test whether they are immune. And if they are not immune, we would give them the vaccine. And then if they don't respond to the vaccine, we will do this. And then if they are exposed to blood while they provide first aid, we will do this whenever an accident occurs. So you can see the test, how we will do it, who we do it on, and we do it at baseline or following the baseline results or whenever an incident occurs. And then what do we do with the results? These are the actions. So immune employees will know, and if you're not immune, we will do this, and so on and so forth. The next one would be noise exposure. So we've done the HIRA, etc., and you can see we give an introduction. The legal references, we also got HSE reports in here for the noise underwater that we spoke about earlier, SANS 10083, Circular Instruction 171, and so forth, and then the medical surveillance. We'll do pre-audiometric examination. What will we do? I'll look in the person's ear, and they'll do a questionnaire, and the questionnaire will have these things, and then we'll look in the ears to look for earwax, etc. Who would be? This would be the divers, and that will be before each audiometric examination. And then we'll do hearing tests, and we'll do all of these. This is SANS 10083, and it will be on divers, and we'll do periodic screening also on the divers at baseline and with the diving medical. And this is what we will do, and you can see, boom, 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 based on the results of the audiogram. It's not just, I go for my audiogram, what do we do with it? Well, we put it in a file. And then next year, we'll put it in the file. And next year, we'll put it in the file. And does it ever go to the employer? No. So why do you have a hearing test every year? Doesn't make sense. Eh? And this is for ultraviolet radiation. So you can see the legal references, medical surveillance. We'll do a skin evaluation, and by screening for suspicious-looking lesions, the divers, during their diving medical, any suspicious lesions would be biopsied and sent to the lab, and it would be referred to a dermatologist. And that would be our action, and so on. So these are some examples, and this is reduced to a document. And this document is then sent to the Health and Safety Committee to say, yes, this is how we will be looked after. And this has got nothing to do with the diving medical. It's a comprehensive look at risk management in the workplace. This is level 2 DMP. Thank you.
So thank you very much, Doctor, for the detailed look at the steps, firstly, of the health risk assessment, the hazard that we should consider, also the scope of medicals needed, some symptoms and sources and special considerations for commercial diving, the details on the medical surveillance program. I think that was very valuable information there. We often get asked, so what is a medical surveillance program? And not being OMP, it's sometimes difficult to explain how simple it actually is. But I do think that we should consider maybe putting a warning on this presentation that it is not suitable for sensitive viewers. And that excludes our colleagues from the police service. So with that, I'm gonna open up for a few questions to Dr. Meintjes. So if you can indicate by just putting up your hand, the roving mics are ready for you. So if you can just stand up and introduce yourself.
Thank you. Thank you, Doc. Maybe not particular to the diving environment. I listened to the medical screening from the employer side. And I'm just thinking of my own, where I'm at. I'm also a bomb technician. So our Chief Inspector of Explosives has an issue with the work sends us on an annual screening, medical screening. But when something is found wrong with that member, it is considered for his ears only. The worker or the management cannot get access to that information because it's privileged. So his question is, why are we doing it? Because sometimes this worker or diver or whoever does not declare it to the work or to his employer, and they cannot do any proactive with this information. They cannot react proactive. So is it so that even if it's a work medical, that the manager or the employer itself don't have access to that specific information? That's my question.
Yeah, so that's a very good question. Thank you. So again, the complexity of all the laws. So when it comes to medical surveillance and all those sort of things, the Occupational Health and Safety Act and the regulations are very clear. It's not the doctor doing the medical surveillance, it's the employer. So it says the employer must ensure that medical surveillance and that they do it, and the employer must keep the records for 40 years. The funny thing is that there's also the POPI Act, the Protection of Personal Information Act, that says, yes, the employer must keep these records, but he may never see it. Only doctors and healthcare personnel can see these things unless the employee provides informed consent and all those sort of procedures. And the doctors themselves may not provide this information because this has got nothing to do with the POPI Act. This is the Health Professions Act. And we are regulated by the Health Professions Council that says, should you do this, you will not be a doctor tomorrow. And they will just scrap us from the roll. So this is protected information, and in the POPI Act it is specifically referred to as special information. It belongs to the employer, but they can never get their hands on it. Even an inspector from the Department of Labor, the Occupational Health and Safety Act says the powers of an inspector. An inspector can go into any workplace, demand any document, etc., and they will throw Occupational Health and Safety Act. It's not the only act of South Africa. There's also the POPI Act and the Health Professions Act and those sort of things. So an inspector, and some of our regulations actually capture this, is they say an inspector, all of these things must be available for an inspector upon request, provided that personal medical information may not be provided except to the medical practitioner involved. So this is privileged information. And so it comes to one of my first slides again when I talk to occupational health, and perhaps I'll just go there quickly again. And many people don't understand this context. Is if we work in occupational medicine, we work. Let me just get there quickly. Where is this now? We don't work with an individual. So the only information that we will give to the employer would be about a population. And what happens to this individual, we need to tell him, would the other employees be exposed? Yes or no? And are your controls in place? Yes or no? But what happened to this individual, now he becomes a patient and is no longer an employee because your safety systems have failed. He's now outside of the system, yeah. But you're not even responsible for the payment because it falls under the Compensation Act. Now the problem, of course, is all state departments, including the police, are exempted employer, so it comes from their own pocket. So they do pay for all those tests, and they don't like it, but that's the nature of the beast.
Thank you, Doctor. The predicament you can see here is that the Act has laid a responsibility on the employer. But if the individual does not report the feedback or the illness or exposure, then according to the employer, no, everything is fine. So there's no way that he can actually prevent it to happen to his other employees, and that is my concern about this question. Thanks for that.
But which exposure? So the medical surveillance program would say we've done a HIRA, we know employees are exposed to this, and we are going to send them for medical tests because of the exposure. So it doesn't start on the medical side. The problem is that most employers think medical surveillance starts with a doctor. It starts in the workplace. And based on these hazards, we've done these tests, and all we want to know is, we've done 100 tests, which percentage of them came back positive? And that will tell us whether it's controlled or not. So I'm going to send, so part of this is, you will see the reporting part of the medical surveillance program is one of the headings there, is every year I send to the employer a report and I say, we've seen 90% of your employees, not everybody pitched for their medicals, and of these 99% of them tested negative. And so we just give an indication of feedback to the workplace, but not about an individual.
Any more questions for Dr. Meintjes?
I would just like to ask, it's a question.
Bridget, if you could just stand up, please.
So I created a question here, because I never ask a question. What are doctors doing about fitness to dive versus fit to dive? How do you fit in there?
Yeah, so very, very topical question. And it actually differs around the world. So there are two approaches to these. The one refers to medical fitness to dive. So are you medically fit? And the other one is your physical fitness. So can you swim 2 kilometers in 2 minutes? And, those sort of things. And some countries say this is the responsibility of the employer, and the employer should say that the person is able to cope with the requirements at work, while others want the medical people to do those tests, and they will do some estimations of, for instance, the VO2 max, and that will either be in the form of a submaximal stress test or the step test that is often used. And so many companies, and I think IMCA is also involved for a long time. I think you still require the step test for most companies is recommended. And even before people would go into SAT, for instance, they will do as part of your pre-SAT medical, you would do a SAT, a step test. And then more formally, some would actually do a functional capacity evaluation, where you would actually have the person on an ergometer that is underwater, and you would measure the person's actual VO2 max underwater. So you've got different approaches around the world. In South Africa, I would say it seems like our approach generally would be by a submaximal stress test. So most divers would know every 5 years you're going to run on the treadmill and so forth. And if you seem to be unfit and there's risk factors, then that would be the route. And then there are some doctors that actually, because we see a lot of offshore divers, etc., that they would do the step test as that. So there's a bit of a mix in our context.
Yeah. So can I just ask, because the physical fitness and the mental fitness, I think this is what came across with Amanda's thing. And job performance is undeniable, and the understanding of this is crucial. So we are taking divers into training, and you're wanting us to put them into the field, and the question was, are we training them right? Is, well, are you giving them to us right? So VO2 max is 40. That's a 2,1K run in 19 minutes. It's a 200-meter swim in 2 minutes, but we can give them 8 minutes. And we're getting people in that can't even walk 2,4 kilometers, to let alone run it. So I think we need to relook at that. And then in saying that maybe unkindly is also if we can link in with the health coaching, because that's unlocking the true potential and giving the power back to the person. instead of medical screening and tell them go for a vaccine, tell them to go for this, tell them about fitness, tell them about nutrition, tell them how to empower their immune system, the mental awareness. And I think I presented in IMCA in March this year, and I just want to bring this up from Amanda's as well. Fugaro spoke about their autonomous vehicles. And they said, what's the worst thing that can happen to an autonomous vehicle? Was the question to that speaker. And they said, well, it runs out of communication. And I'm thinking, well, this is the same as the diver. He's running out of communication. He's getting lifestyle diseases. And we are seeing, you know them, our divers who are having all their cardiac bypass, their stents, their diabetes, debilitating things. And then the second question to this guy was, what's the second worst thing that can happen to an autonomous vehicle? So he said, well, it runs out of battery power. And if we run out of battery power, this is where the suicide sets in. And we're seeing that more and more with the commercial diver. So this medical surveillance and the POPI Act and all the rights and all the regulations, let's pull it back into something that's real, something we can action. Let's make sure the fitness of the diver and his understanding of the role that he's going into, because we can't keep fitting a job to a person.
Unfortunately, that's the way the world is going, is you cannot just allow perfect specimens only, like we used to do in the military back then. It is about fitting the job to the person, to say these are the inherent requirements of the job. And to say that you can't dive, and we can't even teach you to dive,
you must remove the statements in the training standards and in the prerequisites. And I understand both. I'm not asking you for the perfect military diver, because people can improve. But at the moment, the bucket is open.
Yeah. So the question is, with all those people that we sent you, which illnesses and which injuries that they get while they were there that we've missed on the medical side?
Well, I was asking you that question with all the ones you are treating. You know, why are they getting these problems?
Nothing.
You know?
It's very rare.
Yeah.
So if you look at diving injuries and diving fatalities, the medical screening very, very rarely contributed to illness and injury. It's procedural things. It's safety issues. We hear about the odd cardiac case and so forth. So cardiac examination is an issue. And then, of course, if you've got a fake medical, that comes out often. But very, very rarely is it a medical condition that contributed to the death of a diver or injury on a diver. You see travel illnesses, you see marine life injuries. Those are the things that we see, but very rarely a unfitness issue. Very rare. In the last 2 years, I've seen 1 or 2.
Yeah, physical fitness.
In order to just maybe not enter into a further dialogue, if we can move on to the next question. Thank you.
Yes, thank you, Doctor, for highlighting again the excellent work that we're doing. I think, which I would like to just put in context is that when we arrive on these scenes, we arrive on these scenes under the Police Act. And most of these scenes are criminal investigations, and there's a lot of legislation that builds up to that part of the recovery. And most of the times, our bodies that we do recover is not a dive. We do not go down to the workplace. It is there's so many instances, and we've had these conversations. And I think George most vividly was one of those. Which I would like to just want to touch on is the smell of bodies. I found myself that over the years that that's one of the key factors of perhaps PTSD and other symptoms that that you can relate to is the smell of a body and the biological stuff that's been released from that body. And we're now looking at moving towards a mask for that part of the recovery. If you don't smell the body that much, it would make the recovery better. Is it worth the effort to move in that direction from a medical perspective, or must we stick to the Vicks and the Buffs as we do, and or just try and be brave?
Well, I will have to look at the details, obviously. I remember, I know exactly what you're talking about because I did forensic medicine in my 4th year, and I decided that's where I will stop it and not specialize in that further. When we give advice on a question like what you are asking now, is we would go into hazard identification. So what you are describing is a specific hazard, and that's a biological hazard / chemical hazard / psychosocial hazard. So maybe 3 hazards in one. And then we go to the next step and we say, well, is this hazard actually a risk? So are we going to see an illness or a disease coming from this? And if the answer is yes, then we say, how am I going to manage it? And that's a hierarchy of controls. You're jumping straight to PPE, which in your context is probably appropriate because you're not going to have engineering controls and robots doing your work for you and those sort of things. So it's likely going to be appropriate, but I think mentally one should go through the hierarchy and just say, are there any administrative and those sort of procedures that one can put in place? And then if not, to say, okay, this is how we're going to manage it, and to think through these procedures clearly. As I stand here and thinking on my feet, I don't know whether that is a specific disease. I hear you on the PTSD. I mean, that's a well-described disease, and that might be the case, that we say based on that alone, there's enough evidence to say we need to protect our employees, and we can't let them by themselves use Buffs and Vicks. As employer, I need to protect my employees, and this is what I'm going to offer them. Some of them might be not affected by it as much, and they might not need it, but that's how I would approach a question like that.
We're focusing on Generation Z. And the younger guys in our team, they're struggling a bit with the bodies.
Yeah, it might be.
I'm just.
Yeah, it might be.
I have to say it.
Yeah, it might be.
Yeah, no,
it might be.
Thank you.
Thank you. Last question for Dr. Meintjes.
Thank you, Dr. Meintjes. My name is Sandile from KwaZulu-Natal. Mine is a comment, particularly around the intersection of POPI Act, the OSH Act, and other responsibilities that exist for medical practitioners, for employers, even employees themselves who are exposed. I would implore that we look at our responsibilities in terms of the various legislations, and then also dovetail that with the removal of certain prohibitions in terms of Section 32 of the POPI Act, because it does take care of that. Otherwise, we will all be defeated, and this session would be meaningless if we were to say we are not going to do certain stuff because of the limitations in terms of POPI Act. Thank you.
So I'm not saying that we're not going to do it. I'm saying that you don't need that information. I can just tell you whether people are overexposed or not and whether the workplace is controlled or not. But you don't need to know the personal details of an employee because occupational medicine is population-based, not individual-based. So if I tell you When I did the hearing tests of all the employees, 50% of them had threshold shifts. Why do you want to know? I want to see this employee's audiogram. You don't need this employee's audiogram. I can show you the statistics of the average threshold shifts of the employees working in that section. And then you say, there's not adequate controls in this workplace because everybody working there has got threshold shifts.
I do agree. I do agree. But I was merely highlighting that there are other interventions, particularly in a case where only one individual has been affected. But that's why I said it's a comment.
Yeah. Are you talking about an occupational disease, for instance?
Yes.
Well, that has got a legal requirement for reporting to the Compensation Commissioner and to the employer, and that's Section 13 of the Act. So there's no issue with that. So that must be reported. But that's directly linked to the workplace. Yeah. But again, you don't need to see the X-ray. Yeah, you just need to say, this is the name of the disease, and you just need to see the WCL22. So there's a specific format. Yeah.
Thank you very much, and thank you once again, Dr. Mankis. I'm going to ask our colleague Kulingile, our valued representative from the Eastern Cape, to just come up and hand you over a small token of our appreciation for all the hard work on 2 presentations, and both well delivered. Thank you very much. It must be documented. So that brings us very nearly to the end of our program for today. And I'm going to ask Sis Jabu to just come do the closing remarks for us and maybe just inform us of the starting time for tomorrow morning. Thank you very much, Jabu.
Good afternoon, colleagues. I hope we are all still awake, and we would like to thank all the presenters for today's sessions. We really gained a lot from their sessions. So, yeah, tomorrow is our last day, and I hope we are all coming back. Our starting time tomorrow, the registration will start at 8 until, I will say 8:30. Can we start at 8:30? I have all the powers, Angit. Can I request that we start at 8:30 so that we can have an, is it okay with you? 8:45. 8:45. Okay. My principals, they say let's stick to 8:45. So can we all be here on time? Because we all want to knock off early and go home. Thank you and safe travels back home.